We would like to welcome all the schools that have joined this session. Today we are going to have our A-Level Mathematics Seminar 2024, and the theme for this session is empowering the mathematics education, bridging the learning gap with the ICT integration. We are really very grateful to the Ministry of Education that has enabled this to happen, that is really collaborating with the different schools to see that the learning gap is really narrowed across the schools. In today's seminar, we shall have an opening prayer and we shall have some opening remarks. In case UIC Tandren is on, they will be able to say something. However, the ministry officials have sent an apology. They will be joining us at around 10 for this session. But I've seen Mr. Moses. Mr. Moses will talk on behalf of them. And then afterwards, we shall dive deep into our discussion. I'm really very grateful to all those schools that have really joined this session. We have very many other schools that are joining. I want to thank you so much for joining the session. I know it is just 9, but by the time we shall reach 9:30, more than 100 schools would have joined this session. We want to thank you so much, dear schools, dear teachers, for connecting online and for embracing technology. Thank you so much. And for the students, I want to assure you that by the time you move out of this session, you'd have gained a lot. Allow me now to welcome St. Mary's Assumpta to lead us in a word of prayer as we kick off this session. St. Mary's Assumpta, unmute and you lead us in a word of prayer.
Good morning, everybody. This is Daphne from St. Mary Assumpta Girls Secondary School. Due to time factor, I think we should start with the opening prayer. So let's humble ourselves and we start the prayer. In the name of the Father, the Son, and the Holy Spirit. God Almighty Father, we thank you for the gift of this day and for the gift of life that you have given us. And we also thank you for this seminar that we are going to hold today, so that it may help us to get empowered in mathematics, as it being a core subject in most of the science subjects and also in the arts. We pray that may you guide us, offer us protection, so that each and everything that we discuss right now may help us in our everyday life and in our examinations. Thank you for all the people who have taken time to organize such a training, and we pray for your guidance throughout. We ask all of this through Christ our Lord. Amen. In the name of the Son and the Holy Spirit.
Well, thank you so much, St. Mary's Assumpta, for the word of prayer. Allow me to welcome everyone that is joining this seminar. Thank you so much for joining. I want to welcome the schools that are going to participate, that are going to discuss in this session. Thank you so much for taking time off your busy schedules and prepare the learners to be ready for the discussion. Last week, we had a similar session where we had about 250 schools join online and we had a good discussion. Today, we have now about 40 schools that have joined in, and I know very many other schools are yet to join in the discussion. We want to assure you that by the end of this seminar, you will not remain the same. When you look at the seminar questions that were shared, you can notice that we gave you around 100 questions that are for your practice. And I want to let you know that once you practice those 100 questions plus that you have, by the time you'll go in for your final exams, you'll be competent in all the different sections. Like we said earlier on, mathematics is a game of practice. That if you want to become better at math, you must keep on practicing on a daily basis. It's not something that you have to do once in a while, but it's something you have to do daily. And by doing so, you become very competent. And at the end of the day, you'll be very good at the subject and you'll be in position to apply it. Allow me now to welcome Mr. Tulia Temba James to give, okay, I think he has dropped. Okay, Mr. James, okay. but I know he is getting back online, and we shall have him back. Now, in today's session, I do hope that all the schools have received the questions. Teachers from the different platforms where we have been sharing these questions. And these are the questions that we are going to discuss today. So today we are going to be dealing with two papers, that is paper 1 and paper 2. And in these two papers, we are going to ensure that we touch each and every section of the paper. We are going to touch pure 1. We are going to be able to touch pure applied mathematics. So we shall ensure that at least we have presentations from each of those sections such that by the end of the day, we are able to gain a lot from the seminar. Teachers are going to be supplementing on each and every number that require input such that we know which mistakes shouldn't we make at the end of the day, such that at least we are ready for our mock examination. So I know very well that those schools that have not yet obtained the questions or that did not receive the questions, these are the questions that we are going to discuss. There are very many questions, and our prayer is that for the children, you do teach, you can print for them a copy in case the resources allow, but in case resources do not allow, you can print one copy, pin it on a notes board, and ask these children to be practicing one number on a daily basis, and they bring it for you for your approval and the marking. So we try to capture all the different sections, and also we have been able to show you what other things you may need in the different topics. So at the end of the seminar questions, you'll find some of the relevant formulas that you need in order for you to pass the mathematics. So at the end of it, you are going to be able to see the different identities, the different formulas, the different integrals that you may need for the different things. And also some of the things that may not be very clear to you, we have been able to put them at the end of the seminar such that you know which package you must hold when you are preparing in for your mathematics exam. So we want to assure you that we are going to gain a lot from this seminar, and we are praying for you that each one of you that is joining in, and our brothers that have not yet joined in, and those who are not in position, that at the end of the day, each one of you goes out with at least an A in mathematics. That is our prayer as a country, because we need very many mathematicians in order for us to be able to solve the placing problems that are really affecting our country. With that, allow me to check whether Mr. Triatemba has come back. Mr. James, in case you are back, kindly, I wanted to give you an opportunity to say something before we dig deep into the seminar. So each of the schools that is going to present will present one number first, and then we shall have a rotation of that nature. So we shall have one number, the teacher supplement, then we go into the different numbers. But also I want to request the schools to take for us some photos of how those children are really sitting in their rooms, such that we can be able to share on how we are creating some change in our different environments where we are, but also to show that really there is a lot we can do with one gadget at our schools. With that, I'm not seeing Mr. James on the call, much as he really wanted to share something, but we shall be able to get in. So our first school that is going to present is going to be Wanyange Girls. And then after, all the schools that have co-host rights will come in to do the presentation. Mr. Samuel from Wanyange, you are most welcome, and kindly take us through your first presentation.
Hello.
Yes, Mr. Samuel, you are very clear.
Good morning.
Good morning, Mr. Samuel.
Yeah, we are glad to be part of this session. And here are the daughters of Senior 6 Wanyang Girls Secondary School, quite set present to us in their various numbers they organized. So without taking much time, I would like to present to you the first presenter. Thank you so much. Please, daughter, take charge.
Thank you so much. Hi, everyone. My name is Antonio Caroline, a student of Wanyangal Secondary School. Well, I'm going to take you to number 7, and I'm going to begin with part A. And the question is, the coefficients of x squared and x cubed in the expansion of this are A and B respectively. And they're telling us to find the value of A, the value of A over B. So, using binomial expansion, binomial means an expression with 2 terms. For example, x plus 1. So, the expansion of this expression with an index A is the same as n, the combination is 0, x power n minus 1 times 1 power 0 plus n, the combination 1 times x power n minus 2 times 1 power 1. So our x value keeps on decreasing, the index of the x value keeps on decreasing, as the one for y keeps on increasing. So in our question, we have this expression. So according to this expansion, we shall have our x value as 3 and our y value as negative 2x. So this will give us and the combination let me expand my board. So this is 5 plus, times our y value is negative 2x. So, according to our question, that told us they want the coefficients in the expansion of x squared and x cubed. So we are ready to end on the x cubed. So when you place in the calculator, our n is 6. First of all, let me put for you. According to this expression, our x is 3 and our y is negative 2x and our n is 6. So this one is the same as 6. You have to substitute in 0. Press your substitute your n value, which is 6, the index, as you can see. Then you paste this into the calculator. 6 in combination with 0 times 3, power 6 times negative 2x power 0, which is 1. So when you enter into the calculator, you get this as 729 minus 2,916x. When you enter also this, you get 4,860x squared minus 4,000 negative 4,320x cubed. But in our question, that told us to find the value of A over B. And that told us the value of A is the coefficient of x squared and B is the coefficient of x cubed. Therefore, A over B will be the same as the coefficient of x squared, which is 4,860 divided by negative 4,320 as the coefficient of B. So this can be simplified further as when you divide this over this, you get 7 over 18, which is the negative. So, well, that has been our number 7 part A. So we are continuing with number 7, part B, imaginary 1. So for this part B, they're telling us, the question is, find the coefficient of x in the x function of 2x minus 1 over x power 5. But this one can be written as the same as 2x minus so using so according to this, our n would be 5 and our a would be 2x and our b would be negative x power negative 1. So you're going to substitute this in our formula. So u r plus 1, and then in our formula we don't have r. So we are going to first find the value of r. So u plus r will give us c. Our n is 5, and we don't know our r times a, which is 2x power 5 minus r. 5 is our r times our b, which is negative x power r. So this one is the same as c, the same as 5 in combination r times 2, yeah, open the brackets, power 5 minus r times x power 5 minus r times negative. This negative x power negative 1, there is a silent 1 here. So we can write this as negative 1 power. Remember this one? This negative 1 is affecting everything here. So negative 1 times r will be negative r times our x power negative r. We continue. 5 combination r. So we are going to collect the like terms. The x will come together and this, the cosines will also come together. So we shall have 2, 5. So we bring here our negative 1, our negative r times x 5 power negative 5 minus r times x power negative r. So this will give us 5 in combination r times 2 power 5 minus r times negative 1 power negative r. Remember, these ones are the same bases, so we shall add the powers. This will give us x power 5 minus 2r. So, in our question, they've told us to find the coefficient of x in that expansion. So, for coefficient of x, the power of x will equal to 1. 5 minus 2r is equal to 1. So this one will move this side and shall have negative 2r, giving us 1 minus 5. So this is negative 2r, giving us negative 4. Therefore, when you divide all through by negative 2, we shall have r as 2. So we go back and substitute in our formula, in our expression, which is UR, so to be 2 plus 1, giving us 5 in combination with R, which is 2. As you can see here, times 2 power 5 minus R, which is 2, times negative 1 power negative R, which is 2, times x power 5 minus 2. But remember, we are multiplying with R, which is 2. This is the same as 5 in combination 2 times 5 minus 2, we shall get 2 times negative 1 times x. 5 minus 2 times 2, which is 4. So 5 minus 4, we shall get 1, which remains x. So when you enter this into the calculator, you get 8x. Because this negative 1 power negative 2, it remains 1. And when you multiply with everything, we shall end with this. So remember in our question that told us to find the coefficient of x. Therefore, the coefficient of x is equal to 8. So that is this is our number 7, Roman numeral 1. And we still have the Roman numeral 2, which is, hence find the coefficient of x in the expansion of, in the expansion of 1 plus 3x squared times 2x minus 1 over x power 5. So this one, when you look at it, is the same as this one. And we've already got the expansion of x with the coefficient of x. But then they've given us this one. And when the test hence find the coefficient of x in the expansion, it means you begin from where you ended. So our expansion of this is 8. So we shall have 1 plus 3 x squared times 8 x. So this is the same as 1 times plus this 3x squared times 8x. So we shall have 1 times 8x, which is, don't forget the equal signs. So this will give us 8x plus 3 times 8 and x cubed times x squared times x, we shall have x squared, x cubed. So you enter into the calculator. Okay. So we shall have here 240 x cubed. And remember, in our question, they told us to find the coefficient of x in this expansion. As you can see, x is here. Therefore, the coefficient of x still is 8. So that is our number 7. Thank you for listening.
Thank you so much.
Any question where you don't understood, please, you can go on and ask.
Okay, thank you so much, Wanyange girls. In case you have any question concerning the expansion, the binomial, or on that number, kindly raise up your hand and ask. Yes, in case you have any questions, kindly ask. Okay. I think people are well conversant. So those schools that tried out, kindly just confirm your answer, that those are the same answers you obtained. Thank you so much. Wanyange, kindly take us through the second number.
Thank you so much.
Yes. So dear students, when you are attempting such numbers, make sure you follow the different steps. Do not jump the steps, because that particular step you may be jumping might be the step that they are going to use to award the marks. So do not jump the steps and clearly state the binomial expansion. You don't need to cram those expansions. Those expansions can be got from your logbook. Always ask for that logbook in order for you to look at some of those formulas that you may not be having on your head. So those formulas are always provided to you to make your work much, much easier. Okay, Wanyange, you can go on.
Good morning, everyone. My name is Navagesa Raminda from Wanyange Girls Secondary School, and I'm going to take you through number 35 under trigonometry. So we are going to start with part A. And it goes, so cosine 2 theta equals 2 theta 4 negative So we are going to solve this equation for the angles of theta greater than negative 180 in that change. So we are going to solve this equation for the angles that are less than or equal to 180 degrees, but greater than or less, greater or equal to negative 180 degrees. So we are going to using double angles. We can see that this sine theta can be expressed in the identity of double angles, which is sine theta is equal to 2 sine theta cos theta. So we are going to substitute this in our original equation, which is 2 to be 2 into 2 sine theta. Theta equals to 3 cos theta. So from here, we are going to multiply through by 2. Shall get 4 sine theta for theta equals to 3 cos theta. So I'm going to bring this 3 cos theta to this other side. It's going to cross the equal signs. And it will be 4 sine theta cos theta minus 3 cos theta equals to 0. So we have a common, which is cos theta. I'm going to put it out. And I will have cos theta into 4 sine theta equals to 0. So from this step, we can see that cos theta, either cos theta equals to 0 or 4 sine theta minus 3 equals to 0. We are going to have either cos theta equals to 0. We are going to get theta, which will be cos inverse of 0. When you press this in your calculator, it will be angle 90. So we are going to locate for other angles using the Cartesian plane. So we have here 0 degrees, 360 degrees. We have here 90 degrees, here 180 degrees, and here 270 degrees. So from here, since 90 degrees is, we are going to locate first it's in this quadrant and this quadrant. So we shall have our 90 in this quadrant and our other 90 degrees in this quadrant. So according to our range, we have a negative 180 and a positive 180. So we're going to move both in the negative side and in the positive direction. So when I move positively, I stop there, and that will be 90 degrees. When I'm to move again in the positive direction, I'm supposed to stop here. But this 270 degrees, this 270 degrees is above the range that we have been given, so we don't indicate it. Then when we are to move in the negative direction, we have angle negative 90 degrees. And if we are to move again in the negative direction, we find ourselves having a negative 270, which is not within the range. So for this part, we shall have angles theta as positive or negative 90 degrees. So we move to the other side. We say that either cos theta equals to 0 or 4 sine theta minus 3 equals to 0. So the negative 3 is going to cross the equal signs. We shall get 4 sine theta equals to 3. When we divide through by 4, we shall have sine theta equals to 3 over 4. Therefore, our theta will be sine inverse 3 over 4. So now from here, when you cross in the calculator, 3 over 4, sine inverse 3 over 4 is the same as 48.6 degrees. So we shall have our Cartesian plane with 90 here, 0 degrees, 360 here, 270, and 180 degrees. So our sine is found in this quadrant, in the first and the second quadrant. So we shall have angle 48.6 degrees, even this side 40.6 degrees. So we shall move in the positive direction, and therefore our angle theta is 48.6 degrees. So from here, we are going to move again in our direction. And when I move again, I stop here. This will be 180 degrees minus 48.6 degrees, which is 131.4 degrees. So if we are to move in the negative direction, when we are to move in the negative direction, you find that when we move from here up to here, the angle is out of the range of negative 180 degrees. So we don't plane, and therefore we don't have answers for the negative direction. And our solutions for theta will be, you have to arrange them in the what? From descending to ascending order. We shall have negative 90 degrees, shall have 48.6 degrees, 90 degrees, and then 131.4 degrees. And this will be our solution angles for theta. That is part A. So allow me to go through part B, unless you have any questions.
In a school with a question, I'm going to ask Teacher Samuel, can we try to see whether we can, okay, but I think now it's a bit better, the camera. Yes, I'm going to ask the schools to bear with the quality, but we are going to make it much better. They're trying their best. Okay. Any question on that? Okay, I think we can proceed, Wanyang.
No, clear.
So we go to our part B. Our part B is saying that solve sine theta minus sine 4 theta equals to sine 2 So I'm changing my location. The number is kind of long. Sine theta minus sine 3 theta. For angles of theta, I'm going to make a correction in this range. So our range will be for angles of theta less than or equal to pi, but greater or equal to negative pi, instead of it being theta again here. So as you look at this equation, we are going to use factor formula. So I'm going to collect even ones together, and I will have sine theta plus sine theta equals to sine 2 theta plus sine 4. So here we are seeing a sine plus a sine, and when we are to use, as I said, we are going to use factor formula. Using factor formula, a sine plus a sine, you get 2 sine theta plus 3 theta divided by 2 cos theta minus 3 theta over 2 equals to even here we are seeing a sine plus a sine, so we shall have 2 sine 2 theta plus 4 over 2 cos 2 theta minus 4 theta divided by 2. So we shall have 2 sine theta plus 3 theta, we get 4 theta over 2, we shall have 2. Then we shall have cos of negative theta minus 3 theta, we shall have negative 2 theta divided by 2, we shall have negative theta equals to 2 sine 2 theta plus 4 theta, we get 6 theta. When we divide through by 2, we get 6 theta. When you divide through by 2, we get 3 theta cos 2 theta minus 4 theta, we get negative 2 theta. Divide by 2, we get a negative theta. So these twos, when we divide through by 2, the twos cancel, and then we shall have sine theta. A negative cannot affect a cos, so a cos of a negative angle is the same as cos of a positive angle. So we shall have sine 2 theta cos theta equals to sine 3 theta cos theta. As I told you that a cos of a negative angle is a positive angle. positive cos. So from here, I'm going to bring this towards the equal side. So I'll have sine 2 theta cos theta minus sine 3 theta cos theta equals to 0. So from here, we shall have, we pull out the common one, which is cos theta. So cos theta into sine 2 minus sine 3 theta equals to 0. So
Font. Find about the font.
we are having either cos theta equals to 0. So theta will be equal to cos inverse of 0. Theta equals to 90 degrees. If you press this in the curve, you shall have 90 degrees. So when I draw my plane, I have 0 degrees here, 360 degrees here, 90, 180 degrees, and then 270 degrees. So we are having a 90 and then a 90 here, because cos is found in this quadrant, first quadrant and the fourth quadrant. So according to our range that we were given, we are supposed to move both in the negative and the positive direction. So when I move positively, I get 90 degrees, which is within the range. So this is 90 degrees. And then when I move negatively, I get a negative 90 degrees. But remember, our range is within pi, so I can't move again because it will be beyond the limits. So we go to our OR. Our OR is sine 2 theta minus sine 3 theta equals to 0. So from here, we can also still use double angle. I mean factor formula. We are going to use factor formula. So factor formula, a sine minus a sine, we shall get 2 cos 2 theta plus 3 theta over 2 sine 2 theta minus 3 theta over 2 equals to 0. So from there, at 2 theta plus 5 plus 3 theta, we get 5 theta. 5 theta divided by 2, we get 5 over, so we shall have 2 cos 5 theta over 2 sine 2 theta minus 3 theta, we get negative theta divided by 2, we shall still have negative theta over 2 equals to 0. So when we divide through by, now this sign, sign is affected by the negative. Sign of a negative angle is the same as negative sign of a positive angle. So I'm going to pull out this negative, and when I factor it out, it will affect the whole equation, and I will have negative 2 cos 5 theta over 2 sine theta over 2 equals to 0. So when I divide through by -2, I get cos 5/2 theta sin theta/2 equals to 0. So from here, either cos 5 theta/2 equals to, or sin theta/2 will be equal to 0. So this will be cos inverse over 2 theta equal to cos inverse of 0. So cos inverse of 0 is 90. But since we have a new angle, we are going to get a new limit, which will be multiplied through by our previous limit. So it will be -5/2 pi 5 So this will be our new limit. So our angle is supposed to find have to lie in this limit. So 90 degrees, cos inverse theta is the same as 90 degrees. So we shall again draw our, to help us put up Cartesian plane to help us locate the angles. So we shall have our 90 degrees in the first and fourth quadrant. So when you move in the positive direction, our 5/2 theta are equal to cos are equal to 90 degrees. And then if I'm to move in the negative direction, I will have -90 degrees. So these angles that I've gotten, I will cumulate them to reach the new limit that I have formed. So across a sign for you to cumulate the angles, you add 360 degrees to a positive angle. And if it's a negative angle, you subtract -360 degrees. If it's a negative angle for tan, you cumulate by subtracting 180 degrees, and if it's a positive angle, you're cumulating for a tan, you add 180 degrees. Here it means you're going to, on this you're going to add 360 degrees and you get 450 degrees. From here, since it's a negative angle, we are going to subtract. We shall have -450 degrees. So this is the same as positive 90 degrees, and then also positive -450 degrees. But these are equal to, when I multiply through by 2, I will get 5 theta equal to +or degrees ±900 degrees. But we are looking for theta. So I'll have to divide through by 5. When I divide through by 5, I get my theta as positive or -36 degrees, and then positive or -180 degrees. So our limit is in terms of pi. So we have to change these degrees to pi. If you stop here, accuracy, you don't get that much for accuracy. So 36 degrees, when you convert them to pi, it's the same as pi over 5. But it's positive or negative. So we shall have again pi. So 180 degrees is the same as pi, but it's positive and also negative. Those are our angles for the first part. For the all part, so for the part, we have sine theta over 2. Yes, equals to 0. So I will have sine inverse. I will have theta over 2 equal to sine inverse of 0. So my theta over 2 is the same as 0 degrees. When I am to draw my plane, I will have 0 degrees here, 60 degrees, and then 90 degrees and 180 degrees to 70 degrees. So, since our first limit, in our first limit we had what? We had negative pi. We had this limit. This limit does not satisfy for theta over 2, so we are going to get a new limit. So we are going to get a new limit, which will be negative pi over 2 . So this is our new limit. So we're going to use this limit to get our new angles. So our theta over 2 will be equal to 0. When you first use the calculator, you get 0 degrees. And then it's either 0 degrees or 60 degrees, but it is beyond our limit. So we shall have only 0 degrees. When you multiply 0 by 2, our theta equals to 0 degrees. When you convert this 0 degrees to pi, we have our theta as 0, pi. So for this, we have only 1, which is still 0. So for here, we are going to collect all our angles at once. So our theta equals to 0. And then we shall have 0. We shall have positive or negative pi over 5. And then we shall have positive or negative pi over 2. Then we shall have positive or negative pi as our final solution. If you have any questions, you can ask.
Okay, thank you so much, Wanyange girls. Someone asked earlier on in the chat to help them understand much better how you obtain the negative angles, mainly for the first number. You can throw some light how you obtain the negative angles. For the other first part,
how you obtain one clarification, how you obtain.
Now, for
part
A, if it was part A, the first part, we had cos theta equals to 0. So theta equals to cos inverse of 0. Therefore, theta equals to. Now we had our range as 180 degrees. We had that range. So from here, this range shows you that you have to get angles in the negative direction and also in the positive side. So you draw your polar Cartesian plane, sorry. So this Cartesian plane helps you to allocate the angles. On this horizon in the first quadrant, We have here 0 degrees and 60 degrees. Here we have 90 degrees. Here we have 180 degrees, and here we have 270 degrees. When you move anti-clockwise, you're moving positively. But if you move clockwise, you're moving negatively. So when moving clockwise, it makes these angles negative. So when you press in the calculator, cos inverse 0 is the same as 90 degrees. So this 90 degrees is here and here. Cos is found in the first quadrant and the fourth quadrant. So from here we have all the angles. Here we have sine, here we have tan, and here we have cos. So here we find their positive cos. So when we press in the calculator, I got cos inverse 0 as 90 degrees. So when we move anti-clockwise, meaning we are moving in the positive direction, our angle 90 stops here. So this makes 90 degrees valid because it is within the limits. So I write my 90 degrees. When I'm to move again, I get 270 degrees, which is beyond my limit. So I don't indicate it even on the Cartesian plane. So when I move negative is when you move clockwise. So when you move clockwise, you're getting the negative angle. When you move negatively, you reach here, and this is negative 90 degrees. So that's how we obtain the negative angles, by moving clockwise on the Cartesian plane.
What is information about how you change to pi, how you bring in the pi? The relationship between the angle degrees and pi.
Now for pi, we know that pi is the same as 180 degrees. So from here, my 180 degrees, you realize that 90 degrees, when I want to change to pi, if 180 degrees are equal to pi, what about 1 degree? 1 degree is the same as that 1 degree times pi over 180 degrees. So this makes it pi over 180 degrees. So if I want to convert 90 degrees to pi, it will be the same as 90 pi over 180 degrees. But when you divide this, it gives you pi over 2. So that's the relationship between pi and degrees. Any question?
Okay, thank you so much for clarification. I've been seeing teacher Azola Javila. Okay, I'm failing. Yes.
Hello.
Yes.
Yes, on the previous number. Previous number. Part A. Of that, part A of that very question, eh?
Yeah.
Like it was sine 2 theta. Sine 2 theta is equal to 3 something there. So what if what if I just factorize out and I say it is 2 sine theta cos theta, and then after I bring the other cos, and then I factorize out the cos, then I found out the angles instead of using the double angle formula.
Can you give me a moment? I try to get what you're saying.
Person me the question.
You're saying it was sine 2.
It was yes. First of all, let me check it out here.
Can you repeat your question, please?
So it was 2 sine 2 theta
Yeah.
is equal to 3 cos theta.
Equals to?
3 cos theta.
Yeah.
Mm.
But here
Then
there were
if,
two.
if I say here, the sine 2 theta is equal to 2 sine theta cos theta.
Okay.
Yes, and then I multiply it together. It will be 4 sine theta cos theta.
Pardon?
It will be like 2, no, it will be 4 sine theta cos theta on the left hand side. And then I bring the other 3 cos theta on the left hand side.
Yeah.
Then after I factorize out the cos theta, can't I work out and solve the angles?
So basically you're saying I was the same as this. Are you trying to mean this?
Yes. No, but
No.
sorry?
Now, the thing is here.
It's not like that, eh?
Not this.
Hmm?
Pardon? You're meaning this.
It was, as I told you, you bring the other 3 cos theta at this side.
Pardon?
Yes. Like that.
From
So
here.
can't I work it out that way?
You want me to
Let me, okay, let me intervene, Teacher Javira. Yes, I think, let me share and I show you what he's really meaning. Let me share my screen. I think he's talking about the alternative approach that we can use. Isn't it, Teacher Javira? Now, Teacher Javira.
Yes, please.
I think you are talking about the alternative approach because you had 2 sine 2 theta is equal to 3 cos of theta. So when you look at sine 2 theta, we know that sine 2 theta can also be written as 2 sine theta cos of theta. So when we get sine 2 theta as this and we substitute it where we have sine 2 theta, it means we shall have 2 into 2 of sine theta cos of theta is equal to 3 cos of theta. So when I open my brackets, I'll have 4 sine of theta cos of theta is equal to 3 cos of theta. So when you collect like terms, we shall have 4 sine of theta cos of theta minus 3 cos of theta is equal to 0. But since cos is common on both sides, it means I can factor it out and I obtain cos theta is equal to 4 sine of theta minus 3 is equal to 0. So when I reach at this point, it means that either I can have my cos of theta is equal to 0, or I can have 4 sine theta minus 3 is equal to 0. So at this point, I'll get my angles for this. And also when I reach here, I'll say 4 sine of theta minus 3 is equal to 0. And then I can say sine of theta is equal to 3 out of 4. And then I continue. So this is what I think Teacher Javira wanted. Teacher Javira, you can supplement.
Yes, it's fine. That's what I wanted.
Okay. Thank you so much. So this is the other alternative approach that someone can use. Okay, it is also very, very fine. Then you can obtain the angles the way she showed us that you can obtain them and you put them in the required range. However, I think let me build up from there. What I wanted to, before I throw more light. Now, when it comes to trigonometry, when it comes to trigonometry, dear students, I want us to take note that trigonometry will always, there is no any pure mathematics paper you are going to find without trigonometry. Trigonometry will always carry two questions. You'll find that there is a question in section A and there is a question in section B, meaning that if you have mastered well, uh, meaning that if you have mastered well your trigonometry, at least you are going to go into the paper when you know you have a lot of marks already secured. So section A and section B, you'll always find something about trigonometry. However, when it comes to trigonometry, what are the major ideas that they test for? One, they are going to be testing, do you know how to use the quadrants in order for you to come up with the angles? So they have been showing us how we can have the quadrants. Do you know how to use them? Do you know when sine is positive? Do you know when tan is positive and cos is positive? Do you know how to deal with those different angles? In case you have remained with sine theta is equal to 3/4, you'll be able to state all the angles that are positive within the given range. So that is some of the things that they test in when it comes to those trigonometric ratios. So mean that if you are to pass any number concerning trigonometry, you must be well conversant with the quadrants. You must know when you are moving this side of the anticlockwise that all my angles are going to be positive. Whenever you are moving below the x-axis as your reference line, it means that your angles are going to be what? Negative. So that one should be at the back of your mind to know that when I'm solving trigonometry, do I know the quadrants? Because the moment you fail to know the quadrants, it might be very hard for you to come up with a solution to the different questions that they do pose to you. Number two, you must be able to know how to derive and apply the different trigonometric identities. As a student of mathematics, those identities are very key. There is not any number you're going to solve and you find that you are not using an identity. So some of those identities are given in your logbooks, meaning that you must check your logbook for those identities that you don't have off head, such that you do not make any errors. It has been found out last year, even the other years, that many students at times they fail the numbers concerning trigonometries because they cannot relate the different identities, because they keep on making mistakes when they're dealing with the different identities. If you cannot derive the identity, please check in your logbook, check for it, ask the teacher for it, ask whenever you are doing a pure math number, you are doing your neighbor, you're going to be doing mocks, ask for those logbooks such that you can be able to check for those different formulas that are given, because you may not have everything at your head, but if you have them already, that is very, very perfect because it will minimize on the time wastage. Number three, never write your angle to 0 decimal place unless it is an exact angle that you have placed your calculator and the angle you have come up with is an exact angle. That is very okay. But if the angle is not an exact angle, take an example. In case you have placed maybe sine inverse and you have dealt with 0.5, you know that this is 30 degrees. So that one is very okay. But if you find that you have placed your sine, maybe sine inverse of maybe let me say 0.3, and you find out that the angle you are obtaining, let me sine inverse of 0.3, and you obtain your angle maybe as 17.4576, something like that. Please don't approximate that. This is approximately equal to 18. No, write your angles to at least 1 decimal place. I write your angle. Now for this case, I can write it as 17.5 degrees, but also we can recommend that write your angle as 17.46 degrees. Never write them to 0 decimal place unless it is an exact sine inverse of 0.5, which gives you the 30 degrees. But for angles that are not exact, make sure that you maintain the number of decimal places to at least 1 decimal place. And in case you are still making more calculations where you're going to use those angles, please continuously at least write them to 2 until you reach the final answer. Then number 3, your final answers must always be arranged in ascending orders. You're going to be making calculations, and those calculations, when they have told you that we are given this kind of range, please and please make sure you write your answer in ascending order. Your final answer. At times, take an example for that particular number we have been doing. You have found out that you were required to calculate two different parts, that the girl calculated two different parts. Meaning that you are making your calculations. At the end of the day, when you are making your conclusion, arrange your angles in ascending order. You have seen her starting from the negative, maybe negative 180 degrees, 0 degrees, 30 degrees, maybe 60 degrees. So arrange them in the ascending order from the smallest to the biggest angle. Do not just conclude and leave anywhere you have calculated. At the end, make your conclusion, because that conclusion you are making, it will carry a mark. They're based on the conclusion you have made, but not to look out for where you have left a different angles, and always be within the range that they have asked you in your conclusion. In case they ask you that the range should be between negative 180 maybe to 180, it means that now your answers you are stating, let them be within that range that they have stated. Do not state in your conclusion any answer are beyond the range that has been given to you. Then when the angles are given in terms of pi, that may be theta less than 2 pi, mean that also your answers must be given in pi, maybe 3/4 pi. Let it be in pi, but not in now the angle format. So look at the range always when you are working out. We have seen students who panic. At times when they're answering their questions, they tend to panic and they forget to look at the ranges being given, because they look at the number and they see it is very easy. But at times they fail to get the final answer because of the out of the range. So please always make sure you are within the range that has been told to you, the range that the question wants. Then for formulas, you have really noticed that at times when you are making your final solutions, you have noticed that you can come up with a quadratic equation. Take an example. You'll find that maybe you have applied the identities and maybe you have ended up with something like this: 5 times a minus 2 is equal to 0. If you look at this, you notice that it requires you to use the quadratic formula. It requires you to solve it quadratically. Then here, as a student, go on and apply the quadratic formula or any other approach. You can let tan theta is equal to y, and then you solve. But you can use the quadratic formula and say now that my tan theta is going to be, now for this particular case, I can say I know the quadratic formula, that it is given by negative b plus minus into b squared minus 4sc out of 2a. Now apply it and say now this is going to be plus minus inside of negative 5 of squared minus 4 times 3 times negative 2, all of it out of 2 times 3. And then this one will be awarded because you have shown that you know how to solve a quadratic equation. So a mark is going to be awarded for you writing the quadratic formula, or what is known as the bulldozer. So this one will be given a mark for solving the quadratic formula. Meaning that now at the end of the day, now once you solve such, you'll have maybe tan of A is equal to 2, and also tan of A is equal to negative a third. Now for this particular one, you are going to find out that you're going to have two different angles when tan of A is equal to 2 and tan A is equal to negative a third. Now after obtaining and working out your solution, identify the quadrant where tan is positive, identify where it is negative. So after obtaining your answers, then make sure you come and arrange them in order that 63.43 degrees, 161.57 degrees to 43, something like that. So make sure you solve it. For those particular numbers that require using the quadratic formula where you have remained with the quadratic equation, please make sure you come up with the final solution. Don't jump, because some of you, I know you are very wise. You are used to quadratic formulas. The moment you see this, you punch it in the calculator and you just write your answer. You just say tan of A, the answer is 2. You have not showed how you have solved. So this step you are jumping might be the marking step that you are jumping. So do not just jump things. And you find this number maybe is carrying 6 marks. So the 6 marks when they're allocating, they'll allocate a mark for you solving the quadratic key equation. So let's avoid jumping steps because we know it already. But let us make sure that we are coherent. Let's have the logic flow of our work such that someone marking your work can be able to notice what we are doing. Okay, let me end here and then we dive into our next part of the presentation. Okay, thank you. Now, next we are going to have, but before, let me first check whether the ministry officials have come. Okay, allow me, okay. I want to thank Wanyange girls for the wonderful presentation, Teacher Samuel, and we are really very grateful and thank you so much, dear girls. We are going to have you back when it comes to paper 2 for mechanics. Okay, now allow me to welcome the principal at the Ministry of Education to have a word to us before we go in for the next presentation. Mr. Ronald, you are most welcome.
Thank you, Mr. Kaziba.
Okay.
Can you hear me?
Yes, you are very clear, Mr. Ronald.
I'm not sure whether that young lady had completed her number. She completed her number?
Yes, she had completed.
Oh, okay. Okay, that is very good. Ladies and gentlemen, dear students, I'm privileged to be joining you this morning and I'm happy to be here. My name is Ronald Dungu and I work with the Ministry of Education in the Government Secondary Department, but I'm also in charge of all secondary schools in West Nile and Acholi region. And for my teachers, I also support, sorry for that. For my teachers, I also support the ministry in deployment of new teachers and transferring of teachers across the country. Among the many things that I do at the ministry, I'm also part of the Digital Agenda committee that is developing the ICT policy for education and also the guidance that will see the digitalization of the education sector in Uganda. I want to thank the Holistic E-Learning Platform, Research Education Network Uganda, RENEW, and of course, Uganda Communications Commission. I don't know if we have any representatives on call. I also want to thank UICT for the partnership that has been running for quite some time to try and close this learning gap. And I want to thank all the schools that are joining in, the teachers who are joining in. This is testimony that we would like to work together, and it is important that we work together. In 2018, we started a discussion with the UCC and RENEW to see how can we connect more schools to internet so that we can close the learning gap. And by 2020, 56 schools have been given reliable internet connectivity. And to date, probably there are about 140 schools on the RENEW network. But our wish as a ministry is to get very many schools on the same network, such that when we are discussing like we are doing today, we don't have challenges of connectivity. I know that the schools that are connecting today, some of us are having challenges with connectivity, and I would like to thank you for struggling through to make sure that you connect. But our wish as a ministry is to ensure that many schools are connected on a reliable internet line. And if your school is connected to a reliable line, then we request that you bring on board the rest of the schools near you. In the session today, we could see a school and neighboring schools sitting in one hall and listening to this discussion. So we encourage you to work together as schools so that we can close this learning gap. So joining such seminars is a good way to utilize the connectivity in your schools. Seminars enhance research, collaboration, creativity and innovation, teamwork, communication, confidence, listening. And I want to say more about listening. When you keep quiet and you listen to somebody explaining a number, and you raise your hand when you want to interject, that is a key skill that we lack within the working class people. Being able to keep quiet and listen and interject only when you are required to do so is a good way as we get into the working class levels. Seminars also develop us into patriotic citizens. We are joining this seminar from all corners of this country. I can see schools from the west, from the east, from the north, West Nile, and also from the central. And this is critical for us to realize that all of us are working together to enable you succeed. And therefore, when you grow up and join the offices we hold, please do not look at only people from your region, from only your school, but allow every other person across this country to work with you. And that is the patriotism we yearn for. So seminars are going to go a long way to help us realize that patriotic nature that we all wish you to have. I know that starting next week, we shall have lessons for Senior 4 and Senior 6, and we will have different subjects running in the evenings, probably from 4:30 to 6. That is something for us to take advantage of. And I know a team of expert teachers is being lined up to support you because we want you to excel in your mocks and finally in the end of year exams. So we would like to encourage the schools that can join in, please join in and take advantage of these sessions. And to my teachers, I would like to encourage you to be part of this, to prepare a lesson and deliver a lesson, encourage other teachers in your staff room so that they can join and be able to deliver lessons to the rest of the country. To the students, as a teacher, I would like to encourage you to think about the teaching profession, to join us as teachers. And luckily enough for you, right now, the science teachers are the biggest earners in the public service. If you're a mathematician and you join the teaching profession, it means that you are going to be a science teacher and you will be the highest paid public servant in this country. So I would like to encourage you to think about the teaching profession as a key sector that you need to join and come and replace us so that you continue closing the learning gap in this country. And finally, all the students in this country will learn the same way and succeed the same way. With those few remarks, I want to wish you great discussions. I'll be here to listen in when I can, but I know that we are going to have very brilliant discussions coming from the many schools that are here. Thank you, Mr. Kaziba, and please let us continue closing the learning gap in Uganda. With those few remarks, I would like to declare this seminar open and wish you the best for today. Thank you.
Thank you so much, Principal, Mr. Ronald. In the chat, people are asking for your contact.
Now, let me also give you an assignment. Whoever wants my contact, you are going to Google. Just go onto Google and type in the names the way you see them on the screen, Ronald plus Dungu. I hope you know how to search, use the search engines. When you type in Ronald plus Dungu, you will get much about me, but also you'll get how to contact me. And I work better online than on phone calls. So that is the assignment I've given you. Thank you.
Thank you so much, Mr. Ronald, for the remarks. And I want also to thank you so much for the great work you are doing for this country. Allow me now to welcome Sentibali Kudembe. Sentibali Kudembe, you are the next. So every school is going to first present for us one number, and then we shall go on like that, like that. So we are going to have Sentibali Kudembe, then we shall go on and have another school. But Sentibali Kudembe, kindly take us through your presentation, one number. Is Sentibali Kudembe ready? Okay. In case Sentibali Kudembe is not set, because I'm not seeing them. Sentibali Kudembe, are you trying to unmute? Okay. Then in case Sentibali Kudembe, then I'm going to ask St. Paul and Paulins. St. Paul.
Yes. Good morning, Mr. Kaziva and everyone on this platform.
Good morning, St. Paul and Paulins.
My name is Teacher S.6 Ronald from St. Paul and Paulins, S.6 Masaka. Mr. Kaziva, I request you to make me a co-host because we've been offline just some time back and our rights were denied when we
Mr.
reconnected.
Okay, maybe do you have another gadget?
Another gadget?
No, like I've made this one your co-host already.
Okay, thank you so much for that.
Okay.
Okay, let us begin. Okay, come here. You are there.
Okay. Good morning, dear listeners. My name is Chomia Kenneth, a student of St. Paul and Paulins in Masaka. I'm going to be taking through area of mathematics, paper 1. Let's open the analysis part number 47. It reads, the figure below shows a solid cuboid A, B, C, D, E, F, G, H, used as a trough in feeding animals. AB is 8 centimeters, BC is 2 centimeters, AE is 8 centimeters. The total surface area of the trough is 180 centimeters squared, and the volume of the trough is V centimeters cubed. Part A, show that V equals to 6x minus 4x cubed out of 3. Okay, let's try to analyze our question. Hope everyone is seeing the mathematical model. We've been told that AB is x centimeters, BC is 2x centimeters, and AE is h centimeters. Then we are required to show that V, which V is our volume, equals to 6x minus 4x cubed out of 3. So we are going to start by Remember, our volume is always base area times height. That's the general formula of finding volume of any mathematical model. So when we look at our model, this is a cuboid in form of a rectangle. We are going to find, let's look for the base. This is our base, A, B, C, and D. So you come and say, my volume is going to be equal to base area times height, but the base area is going to be 2x times x, where this 2x is the length, then this is the width. So I'll be having 2x squared times h as my volume. Therefore, my volume will be equal to 2x squared h. But when we look at the final expression, we are not having h anywhere. So we'll look for either ways of eliminating h. You proceed. In our question, we were given the surface area of our model. So you come, our surface area, we are going to find the surface area of this figure. Remember, the surface area is like the total surface area is always the sum of the area of the figure given. So we are going to find the total area of this figure. You come, our total surface area is going to be equal to, when I start with the base, I'll be having 2x squared. This 2x squared is coming from here. We are having our base as A, B, C, D. So when I find the area of this base, it will be equal to 2x times x, which is the 2x squared. Then remember, this is a solid figure. It's a feeding trough. It's having the opposite side, which is having the same dimension. Say the opposite side to A, B, C, D is E, F, G, and H. It's having the same dimension. So meaning F, G will also be equal to 2x, E, F also be x. And when I find its area, still to be 2x squared. That's why I'm having 2x squared plus 2x squared. Then you proceed plus xh. This is x. When I consider first A, B, E, F, this is in form of a rectangle having, say, our length as x centimeters and width as h centimeters. So when we try to find its area, it will be x times h, then plus the area of the opposite face, say h, T, D, C. It will also be x times h. That's why you see another xh. Then plus, when we consider side B, C, D, and F, it will be having length 2x, then width as h. This h is the height, the same as the h here, here, and here. So this area will be 2x times this h. I'll be having, this is the 2xh, then plus the opposite side, which is A, D, H, E, and it will be 2x times h. You come and try simplifying further, we'll be having the total surface area, which was given the question. It's 180 centimeters squared, equaling to 2x. I've tried to simplify this, and I'm coming up with this. You understand? After summing up all. Then you'll be having, I'm making h the subject because I'm trying to eliminate h in my formula for volume, which is this. You come, try to take x this side, divide by, you come up with something of this nature, where h will be equal to 90 minus 2x squared out of 3. You proceed. Remember, our volume is V equals to 2x squared times h, but you already have your h as this. You come and substitute for h. So my volume V will be equal to the base area, which is 2x squared times our h. You put that expression. You try simplifying further. Hope this x squared will reduce this x. You come with something of this nature after opening the brackets. We will have 18x minus 4x cubed out of 3. Then you separate. When you separate this and divide by 3, you'll be getting 60x minus 4x cubed out of 3, which is the required expression. When we proceed to part B, we are required, so given that x can vary, use calculus to find to 3 significant figures. Okay? 3 significant figures, you have to note that. The value for x for which v is maximum, full stop. Then we are required to justify that this value of x gives a maximum value of v, which is our volume. So now here, we are required to find the value of x for which v is maximum. Remember, our v is the volume. So you're going to come and say, where v is maximum, for v to be maximum, dv dx is always equal to 0. This is differentiation. So you're going to come and differentiate the volume. Remember, our volume is equal to 60x minus 4 out of 3x cubed. That's the expression for our volume. So we're going to differentiate it. You come and introduce d dx both sides. You'll be getting dv dx equal to 60 minus 4x squared. For those who are not well covered that with differentiation, it's just simple. Just come. For example, I'm differentiating this. You're going to come and reduce the power by what? You first drop the power. After dropping the power, then you reduce it by 1. For example, we are differentiating 60x, but this x is to power 1. There is a silent 1. This 1 is going to drop, say, downwards. When it drops, it multiplies by 60. So 60 times 1 will be getting 60. Then x, the power is going to reduce by 1. You'll be having x power 1 minus 1, which will be x to power 0. But any number to power 0 is a 1. That's why I'm having 60. Then you come and differentiate these two, which is, we are going to drop our power, which is 3. So when it drops, we'll be having 4 times 3, which is 12. Then you divide by 3, because I'm having my denominator 3. When you divide 12 by 3, you'll be having 4. This is the 4. Then times our x. Remember, we said when we are differentiating, we reduce the power by 1. So you're going to have x cubed, then minus 1, which will become squared. So this is my expression after differentiating. You proceed. We are asked to find the value of x for which v is maximum. But you have to be knowing that where v is maximum, dv dx is always equal to 0. So you're having your dv dx as 60 minus 4x squared. You come and equate this expression to 0. So you'll be having, I've equated this to 0, and when I try to simplify further, I'll be having x squared equal to 15. So my x will be equal to the root of 15, and x will be equal to 3.87 centimeters. I'm writing to 2 decimal places because the question was requiring to 3 significant figures. So somebody may ask that out here has told us always put to 5, 4. No, here we are going to 4 significant figures, and when we try to count, these are 3 significant figures. Another person may ask, when we are finding the square root, we always get 2 values, negative and positive. Why are we having only 1 value? Remember, we are finding x, which x is length. We can't have negative length. That's why I decided to take the positive answer. Therefore, our x will be 3.87 centimeters. So we also have another part of justification. We are justifying that this value of x gives a maximum value of 3. So on the justification part, this is just like investigating the nature of our value, say x at dv dx. You're going to come and investigate its nature. You come, say you put your value, the value of x, which is 3.87. Then here I put a 0, because at dv dx always having a 0. Then this side we are going to be having LHS, and this side we're going to be having RHS, which L stands for the right-hand side, then this side R stands for the left-hand side. Now what we are going to do, we are going to find that any value of X to the left-hand side. For example, I can use, let's say when you're having like a number line, when X, our X, okay, let's leave it. We are going to use the number, any number, just choose any digit, but to the left-hand side. Don't know whether people are getting it. For example, if our value at dvdx is 3.87, to the left side, I can choose 2. It can be 1, it can be the very 3. You understand? For example, you come, you say your side work, let my X be, me, let's take 2, because it's at the left-hand side. Then you come in the expression of dvdx. You substitute for X, for this case, I've decided to take 2. You come where there's X squared, you put a 2. We'll be having 2 squared, which becomes a 4. Then 4 times the 4, we'll be getting 16. Then 60 minus 16, we'll be getting a positive answer, which is it 44? We'll be getting 44 and it's positive. So you come and you draw. You come and draw a positive gradient. Our positive gradient will be moving upwards like this. This line you're seeing from here up to here. That's for the positive gradient, because we got our answer as positive. You understand? This is horizontal because we are having this as 0. That's why you're seeing this as a horizontal line. Then you come to the left-hand side. You proceed. Now we're going to find that value on the left-hand side of X. Remember, our value for X is 3.87. So look for that value on the left-hand side. It can be 4, 5, 10, whatever. Then me, I'm going to take, let's take 5. Then substitute for 5 in X. It will be 5, say bracket, squared. When you square 5, we'll be getting 25. 25 times 4, you'll be getting 100. Then 100, then 60 minus 100, we'll be getting negative 40. So we are having a negative sign. That's why you're seeing negative here. Meaning we are going to draw a negative gradient. Starting from here, for a negative gradient, it will be sloping downwards. That's why my gradient will come like this. It slopes downwards. So when you look at this, it's in the form of a hill. So you come and conclude that you're having a maximum value of X at dv dx. That was this justification part. They are just interested in this. Understand? So part C, find the maximum value of V. Giving your answer the nearest thing it has cubed. Maximum value, they're asking for the maximum value of V. Yeah? But remember, our V is the volume. You come. This was the expression for finding the V, our volume, 60x minus 4x cubed out of 3. But remember, at maximum, our x was 3.87. You just come and substitute in that expression. You'll be having 60 into x, which x is 3.87 minus 4 into bracket 3.87 cubed out of 3. You try to, when we open the brackets, subtract, we come out with our volume as this. Then our final answer will be this one, which is volume is equal to 155 centimeters cubed. Or else you can come and substitute in our volume. Remember that volume is always base area times height. You may decide not to use this expression and you substitute here. Remember, you're having the value of x already. You also have the expression for h, our height. You come and first find h. After getting h from this expression, then you come back, you substitute for h and x, still be getting the same answer. Any questions?
Do we have any person with a question on that particular number? Okay, thank you, St. Paul and Paulins. Kindly do check and always stick to what the question really wants. Like you have noticed that the question wanted us to write to significant figures. So it is testing for your numerical knowledge on whether you know what significant figures are. Now there, for such questions, whenever they are specific that they want to three significant figures, and for you go on and write to more than the three, it means that you'll miss out on the mark for accuracy. So it means in case you go on and write 3.8745 like that, and the number of significant figures are not to the required number, then you miss out on the accuracy. So please let us be able, let us revise those few concepts such that we do work out. St. Pauline, someone is asking, what if they had asked for the minimum value? What do you have to say about it?
Okay. What if they've asked for a negative, for the minimum value? You're going to come, for example, here, we got our X as 3.87 centimeters, but they were requiring us to find for the maximum value. And I decided to take the positive side of our answer. But what if the question was asking for the minimum value? You come and find the negative, you take the negative value of X. So here, you're going to make this to be negative. Trust me, you get something of this nature. I can't share with you my screen, but it will be like this. It will be in the form of a value, and you conclude that therefore X at X is minimum. Hope you're getting me. Thank you.
Okay, thank you. Yes, thank you for that. Yes, still the minimum value, we shall always equate our derivative to 0. But those questions that ask for the minimum value, it will always depend on the question that has been given to you. But also make sure that you are able to reason, because at times it depends on the particular question that has been given to you. But I think we shall share with you more on this particular thing that requires you to find the minimum and then the minimum values. Okay. 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 Someone is asking to throw more light on part B. Can you first go back to part B and you throw some light?
Okay. Part B. Let me read the question again. Part B, given that X can vary, use calculus to find to three significant figures the value of X for which V is maximum. Then justify that this value of X gives a maximum value V. We are required to find the value of X for which V is maximum. But you have to find the value of X for which V is maximum. You have to be knowing this condition. Where V is maximum, dV dx is always equaling to 0. This is the condition, eh? So you're going to come, our expression is here, eh? V is equaling to 60x minus 4x cubed out of 3. We are going to differentiate by introducing d dx both sides. When we introduce d dx here, I'll be having dv dx. Then I also come and differentiate this part, this side. When I differentiate this, I'll be having, remember we said when differentiating, we drop the power, say this is x to power 1, there is a silent 1. We are going to just drop the power, it multiplies with the coefficient there. Then after dropping the power also reduces by 1. So this is 60, I'm differentiating this 60x, yeah? It is 60x set to power 1. This power 1 is going to drop. We'll be having 60 times 1, then which is a 60. Then we said the power also reduces to 1. Say we are having x to power 1, but minus a 1. We shall be having x to power 0, but any number to power 0 is always that. It is always 1. So that's why you're seeing 60 here. Then you come and differentiate these two. which is 4x cubed out of 3. When we try to differentiate this, you drop this cubed, it will multiply with a 4. You get 4 times 3. You'll be having 12. Then you divide by the denominator, which is 3. That's why I'm having a 4 here. Then times x squared. Where is this squared coming from? Remember, when you differentiate, we reduce the power by 1. So this x cubed, this cubed minus 1, we shall stay with x squared. That's why I'm having my expression as this 60 minus 4x squared. But we are required to find for the value of x. But we know that at where v is maximum, dv dx is equaling to 0. You come and substitute for dv dx. Where there is dv dx, we're going to put this 0. We put a 0. We shall be having 0 here. We're going to put a 0 equaling to 60 minus 4x squared. You try to simplify and find the value of x. When we take this side, it will be equaling to 4x squared equaling to 60. Then divide by 4 both sides, you come up with x squared equaling to 15. Then you apply the square root. Your x will be equaling to 3.87. I'm writing to 2 dp's because the question required us to find 3 significant figures. So hope you know how to find significant figures. Just count. This is 1, 2, 3, and these are 3 significant figures. I take the positive answer. I will not take the negative answer because this is length. We can't have negative length. Thank you.
Thank you, St. Paul. We have some questions. Wanyange.
Yes, thank you for this opportunity. There is where I will say, when volume is maximum, dv dx to be 0. So what if I want to test for volume minimum? What dv dx?
Pardon? Pardon?
You'll say,
yeah,
when volume is maximum, dv dx is 0. What if I'm interested in testing volume minimum? What's dv dx?
Okay, what if you're interested in finding? Okay, then you will use the condition for turning point. The condition stands. But the question was saying maximum. So that's why dv dx will be equal to 0. Or you're getting me, but just not for both, whether maximum or minimum, after using the knowledge of turning point, it will be equal to 0. Or you're getting me, I don't know.
We have got it.
Okay. Thank you. Naila Bisid Annex. Naila Bisid Annex. Okay. Naila Bisida. Okay. Kanjich, you can unmute. Naila, you can go on and ask.
I would like to ask about justifying that this value of x gives a maximum value of x. I didn't understand how he did that one when I justified.
Okay. Let's repeat the justification part. we are required to justify that the value of x gives a maximum value of v. Yeah, we are going to justify. I say that for justification, it's like investigating the nature of our value, say x. You come, you get that very value, which is 3.87. But at the VDX, this value is always 0. That's why you're seeing a 0. And when we are having a 0, we shall having a horizontal gradient. That's why our line will be horizontal, like a horizontal line. It's from here up to here. It's horizontal. This is for this is 0. Then you come and proceed to L. This L stands for the left-hand side. You find for that value on the left-hand side of the value of x. Say our value of x is 3.87. This is the value. Then you find any value of your choice, but to the left-hand side. In other words, it's before this value. So you can choose 2, you can choose 4, you can choose, no, not 4, you can choose 2, it can be 1, you can even move to the negative side if you wish. But I've decided to take 2 because 2 is before this, not so. And when I substitute for 2 here, I'll be getting 2. Say this is where there is x, we are putting a 2. 2 bracket squared, which is a 4. Then 4 times negative, I'll be having negative 16. When I subtract 60 minus 16, I'll be having a positive answer. That's why I'm having a positive sign here. So when I get a positive sign, this implies that to the left-hand side of our value, we are having the curve is always positive, and I'll come and draw a positive gradient. Positive gradient will always be sloping upwards. That's why it's from here moving like this up here. This is the part which indicates my positive gradient. From here, it moves like that up to here. It meets the horizontal gradient. Then you proceed to R, which is the left-hand side. To the left-hand side, you're going to find that value above this. Say you can take 4, you can take 5, you can take 6, whatever. So, for example, I've chosen to move with 5. Put 5 here. You square, I'll be having 5 squared, which is 25 times 4. This is 100. 60 minus 100 will be having negative 40. So, meaning that our answer is negative. That's why you're seeing a negative sign. So, to the right-hand side of our curve, our gradient is negative. So you draw a negative gradient. It will be moving downwards. From here, it flops downwards. Then when you look at this, it's in form of a hill. So this implies that this is the value of x is maximum. But if it was in form of a value, say it's like this, then like this, then like this, it would have been minimum. That's what I can explain.
Okay. Okay, now for this particular question, when you look at the representation of x represents the length of the trough, meaning that we cannot have or obtain, first leave at that point. So we cannot obtain a negative length. So for this particular one, when you obtain your square root, we do not expect you to come up with a negative answer. But still, for this particular one, we may not, or they may not ask you to find the minimum volume. Reason being is that when you look at our derivative has a squared in it. We have 60 minus 4x squared. So even if you put in a negative, it means that you'll get a positive answer. So for this particular one, we cannot obtain anything with we cannot obtain minimum. It can only give us a maximum value. So you cannot obtain minimum because when you look at our expression 60 minus 4x squared, the moment you punch in a negative, you'll get a positive answer. So we can only obtain a maximum value. And the reason why we are not bringing the negative 3.87 is because our length of the trough cannot be a negative answer. We cannot have length when it is negative. So for this particular one, you can only be asked to find a maximum value. Okay, then some people, I think, yes, Teacher Peron, you can make that submission on the justification.
Thank you, sir, and a good morning to all of you. On justification, of course, you can also use the alternative, whereby after getting that value of x, which you have got as 3.87, when you differentiate that volume the second time, so that you get the 2v, then by the x squared, you will get negative 4x. If you substitute the value of x, if it brings you a negative value, it shows that, of course, it will be negative 4 times 3.87, and that brings a negative value, implying that that volume you were looking for is maximum. That's my submission, sir.
Okay, thank you so much. I think, yes, that is very, very true. Okay, so please, that is the alternative that we can actually do for that particular number. Maybe just to make it more clear, let me so that I can share my whiteboard here. So whenever, like what teacher Perna has done, so you can use, in case you don't know how to draw the sketch he has drawn for us, then it means that you are going to go on and then do what teacher Perna has told us. So both alternatives are really very okay and can be used in order for us to make our calculations. So please feel free to use any of any of the alternatives that is easy for you. So whenever teachers told us, so dear students, whenever you find your d squared y, the x squared is less than 0, it means that this one will give you what we call the maximum. In case the squared y, the x squared, in case you find that it is greater than 0, then this is what we call our minimum. In case you find that you are getting is equal to 0, then that is what we call the point of inflection. However, one point I want to emphasize is what we call a jumping of steps. You have really noticed that the student moved directly because we had an integral. He had something like a differentiation of this nature, and he explained to us very well that this one, when you differentiate, you'll end up with 60 minus 4 times 3 when you differentiate. I just want, because some people were confused. So that is how the 3 cancelled. So 60 minus 4, x squared. However, when he reached here, he just gave us x squared is equal to 15 without showing how he obtained up to this point. Now, some of these steps that we keep jumping might be the awarding steps during the marking, meaning that when you miss it, you may end up losing out on that particular mark. So please, before you jump on to the conclusion, you can even let your work have a flow that things are seen. So here you can say this is 4x squared, divide by 4, then that's how you came up with x squared is equal to 15. But I'm very happy the question was really well attempted. So this is part of the questions we have in analysis, and it is very key for you to know how to deal with differentiation, because you are going to find that when it comes to differentiation, you'll find that the numbers are many. When it comes to analysis, differentiation, analysis will contain differentiation, will require integration and differential equations, meaning that it will have 6 questions brought to you, meaning that if you can answer the differentiation, you are very good at integration, you are very good at differential equations. All those topics are related, meaning you'll be very good for you to score an A. Kanjuchi, you can ask, and then I have teacher Martina.
Okay, thank you. I want to first begin by greeting you, or good morning. What I was inquiring is, someone said that the maximum and minimum. I thought that we just consider the x equals to 0, even if it's maximum or minimum, because it's the same thing. And the other thing I'm asking is, does the justification step have max allocated to it?
Yes. Okay.
That is it.
Okay, Saint Paul, do you want to first answer? Saint Paul, you can first tell us.
Okay, thank you, sir. as it was asking, I hope and hopefully it's going to earn its marks convincingly. Thank you.
Okay. Okay, let me ask teacher Naboe to make this submission such children can benefit. Mwalimu Naboe. Mwalimu Fred? Okay, okay. Okay, I think yes. But please, when you are choosing on the values, to choose on either left or right, make sure you choose the value that is below the value, or the exact value. In case now for this particular one, we had 3.87, meaning you must choose a value that is less than 3.87. And let me say 3.2, a value like a 2, as long as it is below. And for the values that are greater, then choose a value that is above 3.87. Take an example, 4 or 5, in order for you to come up with a different gradient. And do not forget that for positive gradient, always you'll be like climbing a hill. For the negative, you are sloping the hill. Then when they tell you to justify means to determine whether the statement is true or false. So you want to determine, is it true or false? So for justification, there will always be a mark. Whenever they ask to justify, always there will be a mark that it will be allocated to you. So the minimum and the maximum, it is the same approach we used. Both of them will equal to 0. But what is going to distinguish is when you get the second derivative. Yes, Mwalimu Nabo, you can go on and make the submission. Okay. Okay, I think we are going to, on this particular question, you can put their questions in the chat. Our teachers are really responding to those questions you are putting in the chat. Yes, Mr. Fred, Mwalimu Fred, you can continue. Okay. Okay, I'm failing to get Mr. Fred. Okay, okay, but he will be coming in. But in case you have any question, kindly place them in the chat. Okay, I want to thank St. Pan Paulins for that wonderful presentation. Thank you so much. We are going to have you back for the second presentation. Allow me now to ask St. Vali Kudembe. St. Vali Kudembe, are you ready?
Yes, we are ready.
Okay, we can start.
Okay.
Good morning, everyone. My name is Chisa from St. Maria. I'm going to present number 5. So it is about polynomials, and this is the polynomial. It's in degree because it has how. So knowing the degree, which it shall help us in the next part, because in the first part they're asking the value of n and m and n. So the first information they have given us the fact of this polynomial, which is x plus 2. To be a factor, that means when dividing this polynomial by this, you have to get remainder as 0. So by remainder theorem, that means when you put the divisor to 0, whereby you get x is equal to -2. So when you substitute this -2 here, that means you will be equal to 0, because this one is a factor of this polynomial. So p of -2 must give us 0. So that means you have to substitute where we see x with a -2. So m into -2 plus n into -2 squared minus 17 into -2 minus 6 has to equal to the remainder, which is 0, because it's the factor. So that means you have, because this is the power is unknown number, that is the negative 8. That means you have 80m, negative 8m plus, since the power is an even number, that means the negative will go away. So we shall have 4n, this negative becomes a positive, plus 34 also, so 17 times 2 also, 34. 34 minus 6 is equal to 0. So our first equation is m, so it is the negative 8m plus 4n. When you subtract, I think you get 28. No? So this is our equation. Equation 1. Using the first, which was a factor. So the next condition which they have given us is that when you divide the polynomial with x minus 2, you get a remainder as 28. So by remainder theorem, let me repeat, by remainder theorem, that means when the divisor is equated to 0, x will be equal to 2. So a polynomial, when you have substituted the 2, will give you the remainder, which is 28. So that means you're going to substitute the 2 into the polynomial. We have m into 2 cubed plus n into 2 squared minus 17 into 2 minus 6 must give us 28. So we have 8m plus 4n have minus what? Minus n minus 34 and so on. Minus 6 must give us 20. So I'm coming this side, please. So we have the second equation as 8m plus 4n minus, because there are two minuses there, so that means the increase, that is minus, that means 34, 6 is minus 40, which is equal to 28. So I have to bring this one also, this 28, this 28, this one also, but I have to subtract. That means our second, so minus 40 minus 6.
4n.
So it is 4n. So to find these variables, m and n, you have to solve them simultaneously. So solving equation 1 and equation 2. So that means you have 8m plus 4n minus. So first equation was 8. The second is 8n plus 4n minus 6 equal to 0. But we have the sum common. So this is 4. The first equation was the first one was negative, not so? So that means When you add, you end at m. So simultaneously by n. So this is 0. This is 8n. When we add, that means you have negative 40, which is equal to 0. So that means you have 8n is equal to 40. N is equal to 5. So this is our value for n. So using equation 1, where we have this one, negative m plus 4, but our n is so plus 28 is equal to, and so we have this is 20 plus 28, 48 also. So that means we have negative 8m equal to negative 40. Our m is equal to is 6. I'm going to add create more space. So values of have n as 5 and m as 6. So part B of the question, hence factorize. Factorize P of x completely. Now we are going to see why I say knowing, because n we got it as so we arrange the equation. So we have 6x cubed plus our n is 5 x squared minus 17 x minus 6. So you have to know the degree of the equation. So the degree of the polynomial is p. So using long division, because they are said to factorize. But since I know that x plus 2 was a factor, x plus 2 was, that means when I use it here, I will use it here. Don't go to the other way, the other long way of try and error, where you have to get the factor then you buy it. So substituting our polynomial into the long division. So the division takes place the degrees is, so we are going to when we are dividing. So x divided by 6x cubed, we have 60x squared. So we multiply back here, get 60x cubed. Multiply here, get 12x squared. So we subtract, this is 0. When you subtract, you get negative 7x squared also, whereby this is just bring also 17x minus 6. So we go back.
7x divided.
It was and this is this. So we are on this one also. So it's 7x divided by x. So we have minus 7x also, because the annex cancels also. So we multiply back. So minus 7x squared. Then when multiply here, we have negative 14 also. 14, negative 14x also. Then when you subtract, this becomes 0, but this becomes positive. 14x becomes positive. That means positive, negative. So you have negative 3x. This one just comes because the subtraction is between this and that. So that means we are still having a factor of x, so we have to simplify. So we have x here, 3x divided by x half minus 3, because it was negative. So when we multiply negative x minus 6 also, so we are subtracting a b. So that means we have 0 and 0. So now we confirm that the examiner here, he was right. He was right. So that means our px will be equal to, that is our polynomial. Remember, we divided and so. And the answer which we got, when you have divided. But remember, they have said completely. So that means we have to factorize both sides. So that means our x is squared 7x. So I can use product. I'm going to use factorization method. So product, multiply here and is it 2. That is negative 18. And also the sum, we take this one, coefficient of x. So the sum is equal to negative 7. So you have to get the factors. The factors. The factors where you add 9 and 2, have 2 times this, you get 18. But remember, one of them must be negative. But to decide which is negative, you depend on the sum. Since the sum is negative, that means this was a negative value. So have 6x squared. We bring my plus 2x minus 9x minus 3. So that we factorize. The common is 2x into 3 plus 1 because sorry. When you remove 2x, you have 3x plus 1. The common is here negative 3 into 3x plus 1. Proceeding. So I'm going to have here create space. So we first remove the common which is 3x plus 1, and the remaining which is 2x minus 3. So that means so our px, because this was only for this, that means our px, that is the polynomial of x, is this 2 plus this on which we use to divide it by long division. So I have factorized completely.
Good.
In this way, I have factorized completely. When you leave your answer here, this is not completely. So thank you for listening to me. Thank you.
Okay, before you go, kindly let the cameraman show them the answer that is not completely, such that students can know that once you leave your answer in that format, you'll miss out. No, there is the first one, this side, the one that, very good. Dear students, in case they ask you to factorize completely and you leave your answer in that format, it means that you have not obtained the final answer, meaning that there are some marks you are going to lose out. More so if at all that quadratic equation can be factored out further. So the moment you see the word completely, factorize completely, it means that you must go up to when nothing can be factorized beyond that point. So always check out whether that quadratic equation has factors. In case it has factors, then kindly make sure you continue up to the last point. Thank you so much. Unless someone has a question, I'm seeing two questions coming in. Yeah, let us start from Yitula SS.
Okay. Our learner, I'm a teacher. Mine is some submission.
Okay.
That my learners. But let us try to make sure that the equations are simplified as much as possible to avoid some errors. For example, where I got an equation where there is negative 8m plus 4n plus 28. So you see, if you use a mathematical eye there, you would see that that one would be simplified by dividing by 4, giving you negative 2m plus n plus 7, which is equal to 0. So the equations become simpler to be solved instead of having very. Then lastly, where you dealt with x minus 2, when the remainder is 28, I will not advise you to say x minus 2 equals 0. For the first case, it was okay. But for the last, x minus 2 equals 0. As we are telling us that x minus 2 is a factor, yet they told us that a remainder. So I would advise you, in that case, for this part x minus 2, where r is not a 0, you can say putting x equals 2. You can say when x equals 2, instead of saying x minus 2 equals 0, because it is a factor. Thank you very much. That is Shawaswa George from Hidra SS.
Thank you so much, Teacher Waswa, for the submission. Okay, I'm seeing, I think Teacher Khalifa Mustafa. Okay, okay, thank you so much. Okay, Lenovo. Okay, I think I'm failing to get those last two hands, but in case of any questions, kindly have them put in the chat. Okay, thank you so much. That is Sentebali Kudembe. We shall have you back for another question you have prepared for us, such that you can discuss for us. Thank you so much, Teacher Azola and your team for the great work. Those who have just joined in, the questions yes. Okay, the questions are in the chat, and I'm going to ask teachers who are on the call to take some photos of your students seated in those seminar rooms where they are attending from. Okay, next we are going to have Cityland College Matuga. After Cityland College, we shall have, I'm seeing Yutula SS, I'm seeing Gulu SS. Kindly get ready. So Cityland College Matuga, kindly let me know whether you are ready, such that you take us through. Unmute Stelland College. Stelland College. Okay, I don't know that they have another device. Matuga, are you? Okay. It seems I'm failing to. Let me just quickly look in the chat and see. Okay. Failing to get Cityland College. Let me ask Yetula SS. Okay. Yetula SS, we can go on as I try to get Matuga and then we get Gul.
Okay. All right. I don't know whether you are seeing us now.
Not yet, your camera is off, but I've asked you to start your video.
Okay. All right, I don't know whether you are now getting us there and the video.
Okay, not yet, your video is still off. Okay, now your video is coming on. Matuga, you can be the next. Okay, I think Itula SS, we are there.
I'm going to take us through question number 15. It's a question here. Question number 15 is saying, we're given a function that express f of x in partial fractions, and this is the function here.
Sit. Two.
Matuga SS, you are coming in after Itula. Yes, Itula, we are doing number 15, everyone on the call. Sorry for the intercepting in. Okay, yes, we can continue.
This form. So we're going to express this function in partial fractions. So such functions
Itula SS, our audio is not so clear. Your audio, the sound is not so clear.
I will start by letting the function of x that is doing x, this function equivalent to constant. So when you look at this expression, it's a
Itula, we are failing really to get the audio. I don't know whether teacher at Itula, we can get one of you. Yes, Odrav SS. Itula, is it possible to?
Talk about it. We're trying to put this. I
Yes.
don't know whether it's there. Yeah, there, Mr. Ronald Kaziba.
Okay. You talk again and I see. We hear.
don't, okay. Go. Okay,
A bit
we're going to express this function and
better.
and this is how we're going to deal with it. So then the first part, so I introduce unknowns, but if I multiply with this, I'm going to make it a linear function.
So here I have the bx plus c over 1 plus 2x squared.
Now, Itula SS, let me ask let's move the laptop a bit closer such that we can be able to pick the voice. We can
Okay.
let the person.
Okay.
Let him get closer to the presenter.
Okay, we're almost there.
Sorry.
Okay. Let's go on.
Continue.
Okay, I think the voice is quite clear now. So that I continue.
Continue.
Okay, thank you. I was trying to say, we're going to express this in person. We're going to in two parts. Then you are saying there are two brackets here. But anyway, the first part, this is a linear function. So I produce an unknown that is A over the first bracket. Then the second, I'm saying that this is a non-factorizable function. So I'm going to introduce unknowns, which if I multiply, then I want to make this a linear function. So this is what I introduce here. So that if I try to simplify this, I multiply this with this denominator here. This has a linear function. So this implies that expressing this, I'm seeing that two here. So expressing this fraction, getting the denominator was the LCM. Getting the LCM of the denominators here, mathematically, the denominator of this and this are going to cancel. So what we shall be left with is the 3x and the denominator of the other side. So this implies that 3x squared bx plus c in the bracket and 1 plus x. So this is what I get as 165. So I'm going to get the unknowns, the A, the B, and the C. So how do I get these unknowns? Simply, I will introduce when I putting x equals to, so I'm going to see. I'll first start by eliminating some of the unknowns, then I get the remaining ones. So here, when I put x is -1, we shall see that it's going to make it 0 and multiply this, it becomes 0. So putting -1 here, remember x is squared. We're saying x is -1 and putting it here is going to be 1 times 2, it's 2. Then plus 1. 2 plus 1 is 3, so we shall be 3a on this side. And then putting -1 here, we shall have, so putting -1 here, we shall have -3, then plus the other side, the a, that is the 3a. So putting -1 here, I will have -3 equals to, remember this was 0. When I substituted -1 here, it makes this 0. So here I have 3a. So this implies that our A equals -1. Now that I've gotten my A, I'm going to substitute some value of x so that I can get the B and the C, the unknowns. So how do I continue from here? Put x equals to 0. So if I put x equals to 0 in my function here, we shall have a 0 here. But then putting x equals to 0, we shall have a 1 here. On this side, we shall have 0. Putting x equals to 0, we shall have x equals to 0. The b is x is 0. We shall be with 1c with c on this side. C times the 1 with c, and then I'm putting 0 here. We shall have the 0. So but remember we got I, which is negative plus C. So negative 1 plus C. This is plus C equals to the unknown A and C. So I'm going to proceed to get my B. So I'm going to shoot for a value of X, which if I substitute here, I can get the value of that. So when I see here, okay, thank you. So I'll come here. I see that if I substitute 1, put X equals 1, putting X equals 1 is this equation. What I'll get is putting 1 here, I'll get 2. The other side. Okay, putting X here, I'll get PS3 equals to, then putting 1 here, I'll get 2 here. So putting 1 here, I'll get B plus C, but remember our C is 1. So multiplying the 2 plus this first, multiplying the 2 plus this first, I'll get 2 plus, remember here is a 2 and B is here. So I'll get a 2B. Then on this side, 2. 1. So 1 times 2 is this, and plus 1 is 3. 3 times 8, but remember 1 is negative 1. So we shall have negative 3 here. It's negative 3 here. So simplifying this, I'll have this side, I'll have 6 plus this 6. This here gives us 4. It gives us 4 equals to 2B. So dividing the whole thing by 2, I'll have my B equals to 2. Now that I've gotten all the unknowns, the A and the C, the B I've gotten it. So this implies that our function 3x over 1 plus x bracket 1 plus 2x squared is going to be, then I substitute our unknowns, the ones we've gotten here in this this function of us. So this is what I get. This implies that our 3x, our function, 1 plus x, 1 plus 2x squared is equivalent to our value of A is negative 1 over 1 plus x, and then our value of B is 2. So substituting 2 here is going to be 2x plus our value of C is 1 over 1 plus 2x squared. So this is simply what we have got here. So after expressing it in partial fractions, this implies that our function f of x. So remember, this is f of x. So you say, therefore, f of x equals to negative 1 plus x plus 2x plus 1 and 1 plus 2x squared. So simply, this is what I get when I express this into partial fractions. So this is part A, 15A. And then question 15B is saying that hence obtain the expression f of x in ascending powers of x. Hence, meaning we're going to continue from what we have already obtained from here. So okay, so continuing from part B, part B is saying that we should obtain the expression f of x in ascending powers of x. But I can simply choose to express this f of x this way. So my f of x equals to negative 1, 1 plus x negative 1. Hope students are not getting confused why I'm doing so, because I'm choosing to take the denominator up. So this is what I get, plus 2x plus 1. Taking the denominator up, I'll have this in bracket 1 plus 2x squared negative 1. So this is the function f of x. So we're going to obtain this in ascending powers of x. So this gives me a clue of expansion. Since we are saying we are having our values here, there is this and there is this. So I'll choose to expand this and I'll choose to expand this, but I'm going to take them one by one. So after expanding, I'll later multiply and bring it back in this function of x. So what do I do from here? Let me start by expanding the first term. That is 1 plus x negative 1. So when I want to expand all of this, I'm going to use binomial expansion to expand these terms I've obtained here. So let me first work in the formula so that we shall use it later. From binomial expansion, 1 plus xn, 1 plus x, the whole bracket raised to power n, we have 1 plus mx, 1 factorial plus n minus 1 x squared 2 factorial. But here, remember, we are asked to get it up to x to power 3. So I'll have plus n minus 1, n minus 2, x to power 3 over 3 factorial. Remember, this power corresponds to the factorial you have here. So this is what I get. So coming to this, I have 1 plus x negative 1. So I'm going to expand this, but I already have a simplified form of it. So I'm going to substitute the values of x and the value of n in this expanded form that I have. So expanding this, I have 1 plus n. N is negative 1. So I drop the power negative 1 here times x which is here. 1 factorial remains 1 plus n which is negative 1. So here I have n minus 1, but remember n is negative 1. So n minus 1 is negative 2. The x I have here is x squared. And then over 2 factorial remains 2. So I have 2 plus my n, which is negative 1. Let me just write it because someone will be confused. And then this is negative 2. So n, which is negative 1 minus 2, is a negative 3. X, which remains here. So here it is to power 3. I have x to power 3. But the factorial of 3 is 6. So I will introduce 6 here. So simplifying this, what do I have? 1 plus, remember this negative affects here, so we have negative x here. Negative times negative is a positive, but the 2 cancels with this, so we shall have plus x squared. And then here, a negative, this is positive 2 times this is negative 6, but the 6 cancels with this, so I will have a negative x squared minus x to power, sorry, it's not x squared, but x to power 3. So this is what I've expanded. Now let me introduce the negative 1 here. Introducing negative 1 plus x, 1, I will have, multiplying this here, I'll have negative 1 plus x minus x squared plus x to power 3. I've already expanded this. Let me come and expand this in this. Okay, I will have my 1 plus 2x squared raised to power negative 1. In this binomial expression, I'll have 1 plus, remember alpha is negative 1. The x here is 2x squared. Factorial 1 remains 1. So plus my n, negative 1. Here it is negative 1 minus 1, so I'll have negative 2. The x is 2x squared. It is raised to power 2. So 2 over 2, the whole thing over 2 factorial. So here it is 2. And I maintain it. But before we continue, the question is telling us we should expand this to x to power 3. So I'll see that this is where I'll choose to stop. The reason is, I'll see that when I expand this, when I simplify this, I'll have x to the power 4. So there's no need to continue simply because we shall even make this somewhere. So I'll simplify this, I'll have 1. This is minus 2x squared. And then this is plus 2. Okay, simplifying this first, I have a 4x to the power 4. Simplifying this, I have 2, and the 2 cancels with this. So I'll have plus 4x to the power 4. But note that this is not in the range of the question given for us. It's supposed to be to x to the power 3, but I have x to the power 4. So I'll simplify this by saying it's a 2x squared. So remember, this is only expanding this, but it was multiplied with a bracket. So what do? I break the bracket here. That is 2x plus 1. Multiply the bracket now with what I've expanded. 2x squared. Okay, space is not enough here. Let me move to this side. So from here, I will continue to multiply. That is 2x plus 1. Bracket 1 minus 2x squared. So multiplying this, I'll have 2x minus 4x power 3 plus 1 minus 2x squared. So simplifying this, I'll have, I want to make it corresponding to that. I'll have 1 plus 2x minus 2x squared minus 4x cubed. So this is what I get. But the question is telling us is to obtain the expression f of x in ascending powers of x. But here, we have gotten 2 values of our f of x, 2 expanded forms of the f of x. First is this. First, it is this. The first is this we obtain. So, the first is this, right? Sorry. The first we obtained is this. So from here. So the second we obtained was this from here, and it is what is there. So I'm going to add this to that to make it a single function of x. So from here, when I bring this, the function, the first I have there is first f of x. I have there is negative 1 plus x minus x squared plus x power 3. Then there is this also. So I'm going to add both of them. I'm going to add the 2 so that I get a single capital f of x. That is this plus 2x minus 2x squared minus 4x cubed. So adding this, what do I get? We shall see that this cancels and it is 0. So I'll have 3x. Adding this, I have negative 3x squared. Adding this is a positive negative minus 3x power 3. So finally, I think this is what the question requires. So I conclude by saying my f of x, therefore, my f of x is equals to 3x minus 3x squared minus 3x cubed. I think that is what the question requires of us, and that is the final expansion, expression of the expression of itself was here in partial fractions, and that is finding the expression f of x in ascending powers of x up to the third term. I mean up to x to the power 3. That is simply what it is. If there is any question or something.
Okay, thank you so much, Itula SS, for the wonderful presentation. The audio became very clear at the end, but I want you to, yes, I want members to please clearly look at how he expressed the equivalent. When you look at the signs he used, Yes, I want you to talk about it briefly and tell children what to do. Why you decided to use those equivalents, not the equal signs.
From here, the reason as to why I'm using equivalent sign here is, remember the question is telling us that we should express it in partial fraction. So to express this in partial fraction, when I start by letting the function f of x to be something on the right-hand side, I cannot simply say that it is equal to, because I'm trying to make it an approximate. So that's why I want to, okay, thank you. So I think this one should be very good. I think why this learner be like this? Because these are constants and they are not known. So this function is just equivalent until when he has maintained it, until when he has gotten out the constants. For example, here we would say equals, because he has already gotten the constants. But here they are unknowns, so it will be just equivalent, but not equal. I think that's what he wants to explain. I think
Okay, thank you so much. Allow me to throw more light on partial fractions. Now, when it comes to partial fractions, dear students, we have basically 4 cases that we must look at in order for us to solve them. Now, under partial fractions, we are going to look at 4 cases, and this is partial, let me say partial fractions. Now, case number 1 that I want us always to pay attention is, if the denominator, we have two types of fractions. We have what we call the proper, and we have what we call the improper fractions that we mainly look at when it comes to partial fractions. So always, before you start your question, first ask yourself, which kind of fraction do I have? Before you panic, before you start answering, first find out, is it a proper, is it an improper fraction? Take an example. When I have 2 polynomials, I have px and maybe I have 2 in x. First find out, we know very well that for something to be an improper, that the degrees in this is our numerator and this is the denominator. It means that whenever the numerator, the degrees in the numerator are above the degrees in the denominator, it means that we shall have an algebraic improper fraction. So you have to first test, and how we handle those partial fractions is always different. Now, case number 1 is that if the denominator of that proper algebraic fraction has 2 distinct linear factors, then it means that the rule we are going to use is, in case I have px plus q divided by ax plus b, and I have another one, let me say cx plus d. It means that when we are dealing with such a case, it means that we shall say that it is equivalent. I'll use the equivalent sign to a out of ax plus b plus my b out of cx plus d. When you look at this kind, you can easily note that this is a proper fraction, because when you look at the numerator, the degree is 1. The highest power of x is 1. When you look in the denominator, you can note that the degree, when you multiply, the degree is 2, because x times x, you get x squared. So the degree is 2, the degree in the numerator is 1, meaning that this is a proper fraction, meaning that for such, when you are applying your concepts, when you are decomposing, when you are separating the denominators, we shall use this. Then case number 2 is when we have the second case, case number 2. If the denominator of that proper algebraic fraction has repeated linear factors, then it means that when you are separating, let me say you have px plus q out of x, b, everything squared. Now here we have repeated. You can note that this one is a quadratic which has the power of 2. So when you look at the degree is 1, the degree in the numerator and the denominator is 2, meaning that still it is a proper fraction. So that means that it is equivalent to having a out of ax plus b plus our b out of ax plus b everything squared. This is when you have what you call repeated linear factors. Ax plus b is a linear factor, meaning, but however, it is repeated because everything is squared. The degree is 2, the degree up is 1. It is a proper. Case number 3 is if the denominator is a proper algebraic fraction, but has a quadratic factor as one of them in the denominator, then it means that when you cannot, when you are separating, then it means that you must bring in another linear factor. So a case in point, when you have px plus q out of ax plus b into cx squared plus d. For such, it means that this one, it can be equivalent to a out of ax plus b plus bx plus c out of cx squared plus d. So now this is the third case. Then the last case that many students do not notice is what you call for an improper fraction. At times when you find that the degree, take an example, when I have px squared plus q out of, let me say, cubed out of px squared plus, let me say, ax squared plus b, something like this. You can notice that the highest power in the numerator is 3. The highest power in the denominator is 2. Please don't just panic and just separate. Now, for such a case, this is a special case because this is an improper fraction. So the way you handle it is not in any way or like how you handle the first one, that you are going to just decompose them, like just separate them. Now for this one requires something special. And for this one, the first thing you have to do is you have to first express it. You have to first express it as a sum of the pronomial, such that you can be in position to obtain what you call a proper fraction. So for that one, you have first express it. And let me just give you a case in point, because at times they are very common when it comes to mock exam. And you find students, for them, they just rush without knowing which kind of fraction are they dealing with. Take an example. You may find even when the powers are the same, you may find such a quadratic expression. You may find something like this. Still now this one, you don't just separate it the way it is. This one, it means that you are going to first express it as a sum of the pronomials. After expressing it as a sum of pronomials, then that's when you go on and then start applying, converting it into a proper fraction. So for such a thing, it means that you have to first come and say, now here I have my 2x squared, I have my 5x minus 11, and I have x squared plus 2x minus 3. So when you do your long, when you work out, you'll find you have something like this. This is going to be x minus 5, then here you have 2, something like this. So it means that this one, you have to make it into a sum of the two different polynomials. So something like this, x squared plus 2x minus 3, which will be equivalent to, now here I will have 2 plus, now I'll have x minus 5 out of x squared plus 2 minus 3. So when you look at how we have expressed, you can note that now this one is a proper fraction. The degree in the numerator is less than the degree in the denominator. Then when you reach here, it means that now you can express this one very well using any of the cases, either case number 1, case number 2, or case number 3. In case this quadratic equation in the numerator has factors, then it means that you go on and express it first as factors. Take an example. When you look at our denominator, I can express this as x minus 1 and 2, I think x plus 3, something like this. So it means that now here it is linear. So you can express it and separate it very well. But first test whether the fraction you are going to deal with is either proper or it is an improper fraction. So this is the case for number 4. Case number 4, where you have an improper fraction. So for an improper fraction, first separate it into what you call a polynomial. then after get in the proper fraction. Now for this case, this is the polynomial part, and then this is the proper fraction before you rush into separating. Because some of you may become very excited, you find such a number, then you just rush and say this is 5x minus 11 out of x minus 1, x plus 3. And then you start separating without testing or knowing whether it is proper or whether it is an improper fraction. Whenever you find that the degrees are the same powers, 2, you find that the degree in the numerator, let me say this is 3 and this is 2, then please, for such cases, first find out how to deal with it. So that is something I wanted to throw more on partial fractions. These numbers are very common. When it comes to section B, you'll find numbers of that nature that are a bit tricky. And for this number, they can combine it with what? Integration. They can say, first express it as a partial fraction, and then after they ask you to integrate. Meaning that when you are mastering integration, you must also have an idea of partial fractions. It will be very crucial for you when you are answering. Okay. Thank you so much. And I want to thank Itula SS for that wonderful presentation. We shall have you back, Itula SS, for another number. But please also, when you look at the binomial expansion, please do not forget that those ones are given in your logbooks. So kindly just go on and then have them there. You don't need to cram everything. You can have it back in your logbook, check there and have it such that at least you do not make any mistake when you are expanding. It is always very painful to see a child failing a number on binomial just because of forgetting the expansion. Yet we can at least do much better if we have the logbook with us and we use them. Thank you so much, Itula SS, for that wonderful presentation. We are really very happy. And then we are okay. We are going to have Cityland College next. Cityland College. Cityland College. We are ready for you. Cityland College. Oh, I don't know why I'm failing to get Cityland College. Let's give them a minute. Cityland College, Cityland College. Okay, I don't know why Stelland College is not getting here. But in case we are failing to get Stelland College, let us go to Gulu SS. Gulu Ame School, we can have you. Gulu Ame SS. As Gulu is getting Gulu. But I know also Elus SS is getting ready. Gulu Ame SS, are you set? Okay, I think we are failing to get Gulu. Let me ask Elus SS, are we set?
Yeah, we want to share our screen.
Okay, perfect. Elus SS, let's continue. Let's go on. Okay. Cityland College, okay. Okay, that is okay.
Hello?
Okay. Okay, now Cityland College?
Yes.
Okay. Okay, I'm going to ask Elus SS to first unshare, and we first have Stelland College, then you come in. Because I'm saying for you are very set. Because
okay.
I don't, okay. Yes, Cityland College, let's come first. And Gul and Elus SS, we shall come. Then Kanjuchi, get ready. We shall have you. Kanjuchi, get ready. Cityland College, unmute and we start. Okay. Now, as they come in, Hello. Yes, Stellant College. Stellant College. Okay. I think they still have some few network issues. Let's give them a few minutes. Okay, but as we give them a few minutes, Stellant College, can we give you a few minutes as Elus SS takes us through? Okay. Let me ask Elus SS, let's continue as we get Stellant College coming after. Yes, you are sharing.
Yes, my name is Mugesamango Patrick, a student of Erusi Secondary School, Navy. I will present question 2 under algebra. It reads, solve the following simultaneous logarithmic equations. Log power of y minus 1 base of 2 equals to 1 plus log power of x base 2. That is our equation 1. And also we have 2 logarithm power of y base of 3 equals to 2 plus log x base of 3. We are calling log y minus 1 base of 2 equals to 1 plus log 2 power of x equation 1. And we have 2 log y of base 3 equals to 2 plus log x base of 3 as our equation 2. From equation 1, we have log 2 power of y minus 1 equals to 1 plus log 2 power of x. We shall now realize that that one is the same as having log power of 2 to the base of 2. That is from our right-hand side. Then plus our log x base of 2. From there, we can now look our right-hand side and we apply the rule of log, which says when we are adding logs of the same basis, but of different powers, we maintain our base and we multiply the powers. That's why from there, we now have log 2 power of 2x. Because when we say 2 times x, we get 2x. And we maintain our left-hand side as log 2 y minus 1. Then from there, also log says, when you are equating logs of the same basis, you can just equate the powers. And that's why down here, we have y minus 1 equals to 2x. So from there, when you try to make x the subject, you'll find that you will divide all through by 2. From right-hand side, you'll get x. From left-hand side, you'll get y minus 1 over 2. And let us call it our equation 3. Now from equation 2, as above, it is 2 log 3 y equals to 2 log 3 of 3. Because now, when we try to express that 2 in terms of the base of 3, we shall find that it is the same as having log 3, 2 log 3 of 3 plus our log 3 x. When we come down, we shall now see that initially, this 2 was the power of 3. That's why you can see that the 2 has gone up there. And also, from the left-hand side, you also have 2 being the initial power of y. That's why we have now y squared. When we come down, we shall now see that when we apply our rule of log in the right-hand side, which still says log of the same bases, we maintain the base, and we multiply the numbers, such that now we have log 3. When we multiply 9 by x, we get our 9x. We maintain our left-hand side as that one. Now we have our base 3 and 3, then our numbers y squared and 9x. Still, we shall apply our rule. We shall equate the numbers, such that now we have y squared equals to 9x, of which now x equals to y squared over 9. And let us call it our equation 4. Now from there, when you try to compare equation 4 and equation 3, there is some similarity. We are saying that x equals to y squared over 9, and from 3, x equals to y minus 2 out of 9. So you can now say over 2, y minus 1 over 2, I mean. You can now say equation 3 equals to equation 4. Equation 3 is y squared over 9 equals to our equation 4, which is y minus 1 over 2. Then from there, when we cross multiply, mathematically we shall now have 2y squared equals to 9 into y minus 1. When we expand the right-hand side, we shall get 9y minus 9. So now we have 2y squared. When we take the negative 9 from the right-hand side, so that we remain with 0 on the right-hand side, we shall now have 2y squared minus 9y plus 9 equals to 0, which has formed for us a quadratic equation. Then we can use our bulldozer method to solve it. So now we have our b is negative 9, our a is 2, and our c is 9. We can now substitute based on our formula, which says y equals negative b plus or minus root of b squared minus 4ac over 2a. Now we can see that the coefficient of y is negative 9. But now from my equation, we even have negative b, meaning the negative and the negative will now turn to positive, and that's why it has that. So now, if we try to express the number under the root, the square of negative 9 is 81 minus 4 times 2 times 9. And if we try to compute that, we shall see that under root we shall have 81 minus 72. The denominator shall be 4. That is now 2 times 2. So when it comes down, we shall see that y equals to 9 plus or minus root of 9 out of 4, of which the root of 9 is clear as 3. Then everything divide by 4. Now we say it is either y equals to 9 plus 3 over 4. Now we can see that 9 minus plus 3 over 4 equals to 12 over 4. And if we divide like 12 by 4, we shall get y equals to 3. Now, y equals to 9 minus 3 over 4. 9 minus 3 gives us 6, and we have our 4. So 6 divided by 4 gives us the value of y, the second value of y as 1.5. Now, it is clear that we now know the various values of y. Let us now come to find the value of x. Now, let's go to the equation 4, which is x equals to y squared over 9. We can now say for y equals to 3, because the first value of y we got is 3, which is up there. Then from our equation, we say x equals to y squared over 9. We shall now substitute where there is y, we place 3. And that's why we have 3 squared over 9. Of which 3 squared is like having 3 times 3, which gives us 9. Then we divide by 9. Then our x equals to 1. Now for y equals to 1.5, still from our equation, x equals to y squared over 9. For our value of y, which is 1.5, we shall square 1.5, then we divide by 9, of which shall get x equals to 0.25. So now finally, we shall find that the value of x equals to 0.25 and y equals to 1.5. And also, the second value of x equals to 1 and the first value of y equals to 3. Unless there's question, then that's where I can stop with the discussion. Thank you very much.
Thank you so much. That is a loose SS. Any questions on that number? Any questions on that number? Okay, I feel everyone has understood well. You can even verify your answers. So for such questions, please, in case time still allows, feel free to go on and verify whether your answers you have obtained are really correct. Thank you so much, Elus SS, for that wonderful presentation. Okay. That was okay. Wanyang Girls has a question. Yes, Wanyang. Wanyang?
Yeah, my daughter has no question, but she would like to present to us another one handling the same.
Oh, okay. It is fine. Okay. Okay. Wanyang, you can show us. They have another way. We can as well present a number.
Are you seeing?
So this is the second approach that Wanyang wants to show us. Yes. But as they get ready, I want to ask Stellan College to get ready, and then Gulu Ame SS, and then Kanjuchi.
Okay, the equation one is like this and the equation two is like this. So my other option is like we are solving for so long of y minus 1. So we shall bring this other log log 2 x going to be equal to 1. So we know that when we are subtracting, we divide their power. We don't divide it. So we shall say log of 2. It's going to be y minus 1 over x equals to 1.
Wanyanga, get close, increase on your volume. It is a bit low. Teacher Samuel, can we get a bit closer? She's a bit low.
All right.
Okay, I was saying that if we have this form, we can bring this other log inside. If we place the input side, then we leave one the other side. But we know that when we are subtracting, we can divide it. Logs of the same bases, we divide. So we shall say log base 2, y minus 1 over x equals to 1. So we shall say y minus 1 over x equals to 2 power 1. But we know the number power 1 is that very number. So we shall have y minus 1 over x equals to 2. So y minus 1 equals to 2x. So we make x the subject by having y minus 1 over 2 equals to x. That will be our equation theory. Then we do the same for this second equation. We make this log to cross the other side by saying log of y squared is going minus log base 3 x is going to be equal to 2. So we do that 7. We shall say log base 3 is going to be y squared over x equals to 2. So we shall remain with y squared over x is going to be equal 3 power 2, which will be y squared over x equals to 9. So y squared will be equal to 9x as our equation 2. So we shall set equation 3. We shall put equation 3 into equation 4. So we shall write our equation 4. Y squared equals to 9x. So we shall say y squared equals to 9 into our x is y minus 1 over 2. So we multiply on both sides. We shall have 2y squared equals to 9y minus 9. So we make the 9, okay, this other was to cross the equal side. We shall have 2y squared minus 9y plus 9 equals to 0. So we put in our formula, the bulldozer formula. We shall have y equals to, since our b is negative, so this side will be a positive 9 plus or negative root of negative 9 squared minus 4 into 2 times 9 over 2 times 2. So we find our values of y. Our y is either y equals to 3 or y equals to 3 over 2. Then we find for x, we shall say y minus 1 over 2 will be 3 minus 1 over 2, which is 1. Then we go on our OA. We shall say x equals to y minus 1 over 2, which equals to 3 over 2 minus 1 over 2, which will give us our x as a quarter. So it will conclude x equals to 1, comma, x equals to a quarter, and y equals to 3, comma, y equals to 3 over 2. Underline. Thank you for listening.
Thank you so much. Yes, that is the alternative approach we can use. Thank you so much, Wanyange. It is also a very simple method that someone can use. Then thank you, Wanyange. I want to maybe throw some more light on one of the numbers. Someone was asking what if the bases are different and the rest of that. Now, when it comes to logarithms, there are basically 5 things you need to know, or what you call the laws of logarithms. And those are the ones that you need to work on in order for you to come up with the different solutions. One is that when you are having logs of the same bases, when you are adding, then it means that we are going to be multiplying. So these are the basics you need as a person. In case maybe you have logarithms and you are you have a x minus log of a y, and you are subtracting 2 logarithms, addition goes with multiplication. Subtraction will always go with the division. So now these are the basics you need to know. And then in case I have log of a x power m, you know that this is the same as m log a of x. So the power will always drop and it comes here. Then when you have log of a 1, this one is automatically equal to 0. Whenever you have any log to any base, as long as you have the number as a 1, then that one will always be equal to 0. Then the other important one, where you want to answer the person who asks, what if the bases are the same? It means that it is you to convert those bases to the base that you feel is easier for you to work out with. Take an example. In case I have a B and I want to convert them to the base I want, then you apply this law. Take an example. In case you want to take them to base K, maybe base C, base D, what you do, you just say log M. I have B here out of log of M. Then I'll have here my A. So you use the change of the base in order for you to come up with that particular one that you are interested in. So you just apply the change of the bases and then you come up with that particular one that you really want to come up with. Because take an example. At times you may find that you're working out a number, let me say log of 5, and maybe this is maybe x plus maybe log of x, maybe 25, is equal to 3. You'll find that the base here is 5, the base here is x, and it may be hard for you now to proceed when you have base 5 and base x, meaning that you must take them, you reason out that which base is easy for me to convert, that I can take it to base what? 5, and then check out, always you'll find that there is some kind of relationship existing between the two, and then you know that I can write this as log 5x, then it means that for this particular one, you can convert it into the same base, because you can either convert it to base x or to match like this one, or convert this to base 5. So in order for you to convert, it means you say this is log x 25, and the common base here, since here they have used log base 5, then apply this rule and say that I write this as log. I want to take to base 5, then I write the number 25 out of log of the base that I want, 5, and then here I have x, meaning that now I have converted this to the base that I want. So that one is really very, very important when you are working out. Then she has also applied this, that whenever I have log AB is equal to C, please do not forget that this one is the same as just you carrying this A here, and then say B is the same as A to power C. So this one is also very, very important when it comes to logarithm. Once you master how to use these laws, then it means that it's going to be very easy for you to pass any number of logarithms in whatever format they set this number into. So you'll be able to answer out. But also I want you always to reason out that in some cases, you may solve a logarithm question and you find that the answers you are getting are negative. We cannot have a negative log, meaning that for such a case, learn how to discard those answers that are not part of the solution. So in your conclusion, take an example. This is the number you have been solving. I don't expect you, in case you solve your quadratic equation and you end up with, let me say, now like for this particular number, in case you solve out and maybe you find out that you are getting answers like x is equal to 5 as your answer, and maybe another answer maybe that is maybe a negative. So I don't expect you that at the at the end of the day, you conclude that I have a negative, that maybe x is equal to negative and this, because we cannot have our base as a negative. So our base for the logarithm cannot be negative, and also our number, we shall not have those negative. So you need to reason out, and for such solutions, discard them, remove them from your conclusion, such that you do not lose out marks for not concluding well, yet you had the right answer. Allow me to end there and then invite Matuga to take us through the presentation. Matuga, you are most welcome, and thank you so much, Wanyange girls. Bishop Chwanuka, is it a question? City Land College? Okay. Bishop, oh.
No,
okay.
no.
Yes.
We want to.
Yes?
We would like to present number 44.
Okay, you are coming on board. You are coming on board. Don't worry. Okay. City Land College?
Hello everyone. Discuss about 17 seconds, part A. Use Mogas theory so that sin power 5 theta sin 5 theta minus 5 sin 3 theta sin. From the Mogas theorem, 1 minus n the same as 2i the same as
Matuga, is it possible we make the camera very clear? On this side, it's not so clear at all. Let the camera stabilize. And then
minus 1 over z power n is equal to I sin n. So here, answer for n equaling to 1, substituting this equation. Wait a minute, from here it's a z power n minus over z power n. It's same as 2i n theta. So from here, so n is 1, z is n is 1, z minus 1, z 1 is z, which is equal to 2i sin x1 sin. So we go back. We have then our product, our n, so 1 over z will be for the 2 sin power 5. So from there, this will be, we'll expand this using the first cos triangle, which is 1 and 1, 1, 2. Same time, from the first cos triangle, we use 1, 10, 10, 5, 1. So we use on the power, we start with the power increase. We'll be decreasing on the power will be z 5, 1, z power 0 plus z power 4, 1 over z power 1 plus that's z power into 1 over z Not forgetting, here we have times 5, here we have 10, and here we have z power 2 over power 3. Then we continue. This will be z power 1 over z plus 1 z power 0 into over power 5. So from there, all of this is equal to I. So from here, 5 will get plus, then sine power 5 is. So from there, we get z power 5 plus 5. Here, z, when you apply it here, you get 5z power z. So, power divided by power, subtract the powers remaining, 5z power 3 plus 10. Here, the powers is reduced to 10z. The power is 3, here the power is 2, so we remain with 10z now, plus 10. Here, the power is 3. Here, the power is 2. So when you reduce, you remain with so from there I get this. And here you remain with so here z squared power z power 3. I'll remain 1 out of negative z plus z power. I have here z that remains 5 over 5 times over power 3 plus. From here I have z power 0. So I remain with 1 out of z, 1 out of z power 5 equaling to 3 to I sine 5. So we arrange our first expression equals z minus 1 z power into power n. So here we have z power 5. We arrange it with this, it will be minus 1 over power 5. We have here z power 5, z power the same as plus with this because they have the same powers. Okay, 5 here we have 10z minus 10 over z. This is equal to 32 I sine 5. So from there, if we compare with this, to compare with this equation. So there we have this. We have it right where there is n or n here will be 5, which 5 is that. Okay, let me just keep step solution with this. This is the z plus 1 z power 5 plus okay about 5 is to the same as z power 3 minus 1 over z power 3 into power 3. I factorize out 10. I remain with z minus 1 over z power 1, the same as 32 I sin 5. So from here, we compare with this equation, which is the same as, will be the same as 2I sin, where there is n sin theta plus n put into I sin 3 plus 10 into, our power is 1, so it will be, our n is so theta equaling to 32 I there. I sin sin 5 theta. Here we get 10 I sin theta plus 20 I sin theta equals 32 I sin 5 theta. So from here, we can factorize out 2I and get theta plus, here remain with 5 sin 3 theta plus, here it's 20, so we remain with 10 sin theta equaling to 2I sin 5 theta. So we divide through by this 2I on both sides. 2I we divide by 2I. So here this and sin theta plus sin theta plus sin theta equaling to, here is so here that is by 2I get 2 sin 5 theta. So our question wanted us to do that 16 sin 5 is equal to 5 theta. So we rearrange sin 5 theta equaling, rearrange sin 5 theta plus
Okay. Okay. I'm going to ask Stelland College to write the solutions on paper. On paper. City Land College, I'm going to ask you because it's not so clear, much as we have got something, but according to the chat, people want more clarification. So I'm going to ask you to take some minutes to write your second solution and the first solution on the paper, and then we shall give you the opportunity because people are interested in knowing more about the de Moivre's theorem. Yes, I wanted to throw some light, but since you have done it, but people may need more clarification. So we shall get back to you, Cityland College. First have your solutions written down, and then we shall be able to follow through. Yes. Hope that can be a bit more clear. And now when you look at this number, they can ask you at first to even prove and then hence or otherwise. So for such a particular number, like what you saw the child do, she had to first state what the de Moivre's theorem and find out the kind of relation. So I'm going to ask Stelland College, kindly first come up with a solution on a piece of paper. Let us write it down very well, and then we can get back to you. We shall give you the opportunity. Hope that is okay.
Okay, sir.
Okay, yeah. Everything was very good, just because I think the camera was really not so good. But kindly write it down, and then we can have you back. Okay. Allow me now to bring in Kanjuchi. Oh, no, let me first let me ask Gulu Kanjuchi. Kanjuchi, are you set? You can, since you have that same number, I think you can do for us part A and we see whether your camera is good. Kanjuchi?
Okay, Kanjuchi, we are ready. Kanjuchi, we are ready, and we are going to present number 49. Number 49, let us open number 49. That's the number we are going to discuss. And we are using another company called the ICT Man. So we are sorry for that.
Okay. Okay. It is well. Okay. We can start, Kanjuchi. Let's have the camera stable. Your volume, Kanjuchi. We can't hear anything. Unmute. Kanjuchi, unmute the microphone.
Yes, can you hear us?
Yes, okay, we can start.
They're telling us to show that cos 3 theta. Cos 3x equals 4 cos 2x minus 3 cos x. So since they have told us to show, we are going to go from the left hand side. So from the left hand side, we are going to expand cos 3x, which if we try to do that from multiple angles, cos 3x is the same as, let's say 2x plus x, the cos of 2x plus x. Since we can express 2x simply, it has some simplified form of identities. So cos 3x is the same as cos 2x plus x. So we are going to expand. Yes, we shall have cos 2x cos x. Since it is addition, we shall subtract sine 2x, sine x. So we are going to express everything here in terms of cos. Since according to where we are going, what we are trying to prove, it is in terms of cos. So we are going to express everything in terms of cos or cosine. Eh? So cos 2x is, in terms of cos, is the same as 2 cos squared x minus 1 multiplied by cos x minus sine 2x. When we expand sine 2x, that's the identity. This is 2 sine x cos x multiplied by sine x. The reason that's why I'm trying to put everything in terms of cos is because what they are trying to tell us to prove is all in terms of cos. So, to simplify further, we shall have 2 cos 2x minus cos x minus 2 sine squared, the sine times the sine, we shall get sine squared x cos x. For which from the Pythagorean identities, sine squared x plus cos squared x is 1. So we shall express sine squared x in terms of cos. Because where we are going, what we are trying to show is in terms of only cos. There is nothing outside. So we shall have 2 cos cubed x minus cos x minus 2 into this sine squared x is the same as 1 minus cos squared x multiplied by cos x. And let's solve it further and see. We shall get 2 cos cubed x minus cos x minus 2 cos x plus, because this is, okay, I'm multiplying directly, cos 2 times the cos x. So we shall add, because it is a negative, 2 times the negative cos 2. So it will be plus 2 cos cubed x, which they are telling us prove that. So if we collect the like terms together, we shall have 2 cos cubed x plus 2 cos cubed x, that is 4 cosine cubed x minus 1 plus minus 2, that is minus 3 cos x. Let's show. So that is what part A of number 59 requires. So part B, the second part of that answer, wanted us to show that if we integrate from 0 to pi over 2 cos cubed x with respect to x, we shall get 2 over 3. That's what part 1. We shall get 2 over 3. And how are we going to go about this? In this expression, this is cos 3x. So from this expression, or this identity, it's even in the log, we have cos cubed x in it. We cannot integrate cos cubed x directly. So we are going to make cos cubed x. We're going to make cos cubed x the subject from this identity. So that we can, if we make it the subject, we shall only have the cos 3x and the cos x, which are easily integrated, or which can easily be integrated. So we are going to first make cos cubed x the subject, this expression, such that we can easily integrate it. I hope it is clear. So, making cos cubed x the subject here, we shall have, because this is negative, it will come this way and become positive. So cos cubed x will be equal to cos 3x plus, because it's going the other hand, plus the 3 cos x minus 6. It still has a 4 in it, but we need only 4. Okay, we only need cos cubed x, so we shall divide the 4 the other side and this side, which the 4 this side will cancel. So it will be a quarter into that. So we shall integrate this because it is equal to this. And these terms in this can easily be integrated. So how shall we go about this? So this will imply that the integral from 0 to pi over 2 from cos 2x with respect to x is equal to the integral from 0 to pi over 2 of a quarter into cos 3x plus 3 cos x, all with respect to x. We are working with respect to x. We shall take out this constant. So if we bring out the constant and integrate the rest, since it is addition, we are going to put an integral sign on this term. Do it. Okay, it will be a quarter into a quarter into the integral from 0 pi over 2 of course 3x plus 3 cos x with respect to x. So we are going to integrate. So since it has names, it is definite. So we shall not have a constant. So we are going to integrate each term, which if we integrate cos 3x, there is some concept when we have multiple angles. We first differentiate that expression of the multiple angle. If we differentiate 3x, we shall get the root, isn't it? So after integrating that multiple angle, yes. Okay, we integrate it and then we differentiate it, differentiate it and integrate the whole term. After integrating the whole term, we divide by the derivative of this. So we shall have 1 over 3, we are dividing. When we differentiate sign, we get a cos. So when we integrate cos, we shall get a sign. Sign derivative. I think it makes sense now. Like we differentiate the multiple and integrate the term, we divide by the derivative. So when we integrate, this is when we integrate 3 cos x, when we differentiate sign, we get a cos. So we integrate will be 3 sin x. The limits are from 0 to pi over 2. So whenever you see this pi, we manipulate everything in radians. So let's try to simplify further. It will be a quarter into a third times the sine of 3 times 5 from the upper limit. We shall get the terms in the upper limit minus those terms in the lower limit. 3 pi over 2. That is a single angle. This is a single angle. Yes. Plus 3 sine. So after the same drawing. We are going to use everything after and that line immediately. So it will get sine 0 plus 3 sine 0. So it is a quarter times everything that we are seeing here. So we put our curve in brackets. So put our curve in brackets. -1. So a third times -1 shall be a quarter into negative at that plus. The sign, this is very powerful. By sign. So it is just pi over 2. Sine of pi over 2 is 1. Yeah, is 1. Minus the sine of 0 in brackets 0 plus the sine of 0 times 3 is 0. All this is 0. So it will be a quarter multiplied by that. We only get 1 and subtract that.
HPB in one position, don't move.
So 1 minus a third, we shall be 2 over 3. Oh, sorry, this was times 3. Sine of 5 over 2 is 1. So times 3. It will be, I will be here. I'm not confusing that. So 3 minus a third would be 8 over 3. Would be a quarter times 8 over 3. Which one we there is a common factor. You can reduce this. So it's 1. So
Okay. Thank you so much. I think we have lost their audio, Kanjuchi. That is really very good. That's what they wanted us to prove. I don't know whether, but I'm seeing some questions. Itula SS. Is it a question? Okay. That is really very nice. When it comes to trigonometric proofs and the rest of that, be very careful. When they say show, please make sure you do the needful. And for the show, we always come from the left-hand side, go towards the right-hand side. For the proof, feel free to come in from any of the ends you want. But for when it is for show, it means that they want you to show that the left-hand side is equal to the right-hand side. And when you see the word hence, it means that they want you to use the previous answer you have obtained in order for you to proceed and do what they have asked you for you to do. But do not forget that when you look at the second part, they wanted you to integrate, meaning that you need to know how to integrate trigonometric functions. So it is very crucial in order for you to know how to integrate those trigonometric functions in order for you to pass such numbers. Thank you so much. Kanjuch, I will ask you to take a photo of that board with the whole number. Yes, use the phones, take a photo of the whole board with the whole number such that you can be able to capture it very well. But thank you so much. It has been a nice presentation. Allow me now to bring in, I don't know, I want to ask whether St. Paul, you are still on. St. Paul, as Gayaza prepares. St. Paul, Anak, are we on?
St. Pan Paulinus Gayaza Masaka.
Oh, no, there is Popo, the sixth Anak. Anak. Anak teachers, I don't know that Teacher Pio is still on. Teacher Pio, is Anak still on? Are they ready to present Anak? Teacher Pio, they can unmute. Teacher Pio, unmute. Teacher Pio. Teacher Pio, you can use your...
Hello.
Yes, yes.
Oh, we are using the different name, but we can use this to present.
Okay. Now you are going to disconnect one audio.
Yeah. Can you hear me now?
Yes, but there is some feedback.
Okay.
So disconnect one audio.
Okay, you turn off that audio. So this is hello. Hello. Hello.
Yes.
Hello.
Yes. We are
Can
clear.
you hear me now?
Yes, we can hear
Okay, thank you.
well.
Okay, this is Popol S.6 Anaka, and we are ready to present.
Okay, we can go on.
Okay, please. So we have some students. I think we have some 2 numbers to present. We are starting with the number 51. So 51, maybe you will use the board. Then focus the camera.
Teacher Sama, we need to get close to the board. Oh, it seems we are losing them. It seems we are losing them. It seems we are losing them. Teacher Pio? Okay. Yes. Okay. But as they get back, let me ask whether Archbishop, unmute. Archbishop, unmute. I'm seeing your hand up.
Yes.
Yes, you can start.
Thank you so much for the opportunity. We are requesting to share our screen.
Kindly go on.
We are presenting number 44. And here is the one who is going to present.
I'm going to ask you to expand it further. Okay. Okay. Okay, you can reduce. Okay. We are good to go.
Okay, hi everyone. I'm Nankanja Bena going to I'm going to present number 44, which is saying a conical section is given by x equals 4 cos theta, y equals 3 sin theta. Show that the conical section is an ellipse and determine the eccentricity. So we have x equals 4 cos theta. We are going to divide both sides by 4. So as to get x over 4 equals to cos theta. And we square both sides, getting cos squared theta equals to x squared over 16. And then after, we get a y equals to 3 sin theta, which will be y over 3 equals to sin theta. And then after, we square both sides to get sin squared theta equals to y squared theta over 9. And then we all know that cos squared theta plus sin squared theta equals to 1. So we substitute x squared over 16 plus y squared over 16 over 9 equals to 1. So which means that the conic section is an ellipse. So on determining the eccentricity, since b is less than 16, we are going to say that b squared equals to a squared into 1 minus e squared. So we have the b squared as 9 and the a squared as 16. So we have 9 equals to 16 into 1 minus e squared. So when on dividing both sides by 16, we have 9 over 16 equals to 1 minus e squared. So we have the e squared equals to 1 minus 9 over 16, getting e squared equals to 7 over 16. When we square both, we root both sides, we get e. We get the eccentricity as root 7 over 4. And then part B is saying that given that the line y equals to mx plus c, that's the tangent to the ellipse x squared over a squared plus y squared over b squared equals 1. They are saying that show c squared equals to a squared m squared. We have a tangent as y equals to mx plus c, and then the ellipse as x squared over a squared plus y squared over b squared equals to 1. So we get the LCM and then multiply the LCM on both sides. So we get x squared b squared plus a squared y squared equals to a squared b squared. Then we're going to get x squared b squared plus a squared into mx plus c squared. That is when we substituting the y equation, which is y equals to mx plus c. So we come x squared b squared plus a squared into mx squared. Into a squared into m squared x squared plus 2cmx plus c squared equals to a squared b squared. And then, so we get x squared b squared plus a squared mx m squared x squared plus 2a squared cmx plus a squared c squared minus ab a squared b squared, equals to 0. And then here we factorize. We put the x squared outside, and when we remain with x squared into b squared plus a squared m squared plus 2a squared c mx plus a squared c squared minus a squared b squared equals to 0. And then we apply the condition of tangents, which is b squared minus 4ac equals to 0. Then we describe. We have a equals to b squared plus a squared m squared, and then b, which is 2a squared cm, and then c equals to a squared c squared minus a squared b squared. And then we substitute in the equation, which is b squared. Here's the b squared. The b squared we get, when we square the b, we get 4a power 4 c squared, then m squared, then minus 4ac, then here's the 4 into the value of a, which is b squared plus a squared m squared. So it is a b squared into a squared c squared minus a squared b squared, which is the c, then plus a m squared into a c squared minus a b squared. So that's it. And then on dividing both sides by 4, and then we get a power 4 c squared m squared minus, but then with the brackets, minus a squared c squared b squared minus a squared b power 4 plus a power 4 c squared m squared plus a power 4 m squared b squared equals to 0. And then we open the brackets and we get a power 4 c squared m squared minus a squared c squared b squared plus, so this negative enters the bracket, and then the negative becomes a positive. So we get a squared c squared b squared plus a squared b power 4 minus a power 4 c squared m squared plus a power 4 m squared b squared equals to 0. So here we have a positive a power 4 c squared m squared and a negative a power 4 c squared m squared. So they cancel and remain with a squared b power 4 minus a squared c squared b squared plus a power 4 m squared b squared equals to 0. So we divide. So we make the a squared c squared b squared the subject, and then we divide both sides by a squared b squared, so as to get c squared equals to b squared plus am squared, a squared m, which was given as it.
Yeah. Thank you so much. I want to find out whether we have schools that may have questions.
Hence, determine the equations of the tangent at the point -3 to the ellipse. X squared over 16 plus y squared over 9 equals to 1. So we have our equation as y equals to mx plus c. So, and we have that, and on making the c the subject, it is c equals to y minus mx. Then at -3, when we square both sides, we get c squared equals to 9m squared plus 18m plus 9, and we make it equation 1. So from our equation of the ellipse, which is x squared over 16 plus y squared over 9 equals to 1, the a squared we have is 16, and then the b squared is 9. Then we substitute in the c squared. We substitute in the c squared equals to b squared plus a squared m squared. So we bring the value of c squared, which is 9m squared plus 18m plus 9 equals to 9 plus 16m squared. After substituting, then we get 16m squared minus 9m squared minus 18 equals to 0. So we get 7m squared minus 18m equals to 0. Then by factorizing, we get m into 7m minus 18 equals to 0. Now, when m, because they told us to determine the equations of the tangent, not the equation of the tangent. So we have to have two equations. So we have when m equals to 0, then our c equals to 3 plus 3m. So that c equals to 3, since m equals to 0, so this becomes a 0. And then we have c equals to 3. Then equation of the tangent, we have y equals to mx plus c. So to be that, because the m is a 0 and then the c is a 3, so we shall get y equals to 3. Then when 7m minus 18 equals to 0, then our m is 18 over 7. Then c equals to 3 plus 3m. Then we substitute in the value of m, which is c equals to 3 plus 3 into 18 over 7. So we get c as 75 over 7. And then we get the equation of the tangent, because we have the m as 18 over 7 and the c as 75 over 7. So we get y equals to 18x over 7 plus 75 over 7. So thank you.
Thank you so much, Archbishop Chiwanuka.
Mr. Kaziba, can you hear us?
Yes, you are very clear. I want to see whether some schools have questions. I'm going to start with Buwanga Secondary School. Unmute and ask your question. Gloria, unmute and ask, as well as the Tula SS.
Yeah, thank you so much. I think you can hear us. My question is like, is there a possibility of you repeating part A because she was very speedy and you couldn't get her to? Thank you.
Okay, thank you, Gloria. Buwanga Secondary School. Okay. Buwanga, we are not getting you. Yetula SS. Okay. I think just throw some light on part A.
Okay, you see, we have x equals to 4 cos theta. So we divide both sides by 4, so as to get x over 4 as the value for cos theta. So on squaring both sides, we get cos squared theta equals to x squared over 16. And then we have the y equals to 3 sine theta. We divide 3 on both sides. And we get the value of sine theta as y over 3. So we square both sides to get sine squared theta equals to y squared over 9. And we all know that cos squared theta plus sine squared theta equals to a 1. So we substitute in the value of sine squared theta and the value of cos squared theta, so as to get x squared over 16 plus y squared over 9 equals to 1, which is an ellipse. And then on getting the eccentricity, we all see that the b squared is less than the a squared. So it is like b squared equals to a squared into 1 minus e squared. Then we have b squared as 9 and the a squared as 16. So we have 9 equals to 16 into 1 minus e squared. So we divide both sides by 16 to get 9 over 16 equals to 1 minus e squared. So we have the e squared equals to 1 minus 9 over 16. So e squared equals to 7 over 16. Now we have our eccentricity as root 7 over 4. So that's it. Yeah.
Thank you so much. Someone who wanted, now, please do not forget, when it comes to the equation for ellipse, it will always be a plus. X squared out of a squared plus y squared out of b squared is equal to 1. That is when it comes to ellipse. And when you find that it is a subtraction, then you know that one is an hyperbola. So hyperbola, your eccentricity is greater than 1, and you'll always have the general equation as a minus. So you must pay attention to it. And when it comes to eccentricity, it means that for it, you'll have b squared is equal to a squared, then open brackets e squared minus 1. That's when it is for an hyperbola. So those are the two common ones, that two common planes that they can ask you when it comes to the conic section, but also they can ask for the parabola. It is also very common. So the number she has been handling, it is in conic section. And for this section, also you must have an idea of differentiation because you need it in the process. I understand for part B, we may have another alternative approach that can be used other than what she has used. And I'm going to ask her, in case you have those schools that have that option, kindly take a photo and share it in the chat such that people can look at it. But also I'm going to ask Archbishop Chuanuka to share their solution in the chat such that schools can be able to download and then they follow it up. Thank you so much for the wonderful presentation, Archbishop Chuanuka, all away from Masaka. Thank you so much. Now next, we are going to, okay. Gulu Ame SS. Gulu Ame SS. Gulu Ame SS.